getting your hands dirty. In this lesson, we are going to immediately start writing a little bit of JavaScript. So what I would like you to do is follow along with me and go to codepen.io. If you don't have an account, you can make a brand new account absolutely for free. And then once you were signed in, you can just click pen. And this is going to allow you to create a brand new code pen. And this lets you write HTML, CSS, and JavaScript together. Now, I'm not going to be using JavaScript, or not JavaScript, we are going to be using JavaScript. I'm not going to be using CSS or HTML right away. So I'm just going to scroll those up and sort of get them out of here. I'm going to close this ad and go over to console. And this is effectively reproducing what we have in front of us, a browser. So it gives us HTML, CSS, and JavaScript, and a console. We'll get into this with a default browser in just a little bit as well. But first things first, let's go ahead and in this JS section over here, see if I can make this larger. Let's just simply write alert hello world. And we see that this shows up with hello world. That's exactly what we wrote. So we click OK, and that effectively is JavaScript. So now what we've done here is we've called a function called alert. We'll talk about functions in its own particular series of videos as well. But this is a function, and inside of this is a sentence, which we use a quotation mark at the beginning and a quotation mark at the end, and then a bunch of words or whatever we want to put in the middle. We have these opening and closing parentheses, and then over here, we have a semicolon, which is technically optional, but it's a good practice to have it in there anyways. And what this does is anytime you load your page, it's going to say hello world. We could make this say anything else. Hello, Caleb, me, your teacher. And just give it a sec and it says hello, Caleb. That's it. That's all we need to do. Now, we're actually not going to be using alert too much, so honestly, that's somewhat of a useless example, but it does show you that it can trigger events in your browser. And that's pretty cool. We are going to be using console a lot. That's why I have the console open. So what we can do is type console.log, hello, Caleb. And if you just give that a second to refresh, because I typed too slow there, it said hello, Ka. But the second time around after it refreshed, it said hello, Caleb. We can always clear that as well and just redo that. And we could say hello, Zephyr. And again, I typed too slow there, but we could say hello, Zephyr, and then just console logs. And so this actually doesn't show up on the page at all. The page is this white section here, and we'll get more familiar with this as we progress through this course. The console is where we're going to do a lot of debugging. Now, if you're ever wondering what this is actually like, we could always right-click on any page in our browser, go to Inspect, and if we go over to our console, this is where all of our code is happening. It's right in the console. So we could clear this console with Control-L or Command-K, and that just clears it. And if I make this just a wee bigger, and again, this is just the console that lives on every page. All I did to get there was right-click Inspect. It might open you up to elements. You just have to go over to Console, and then I scrolled it up. And in here, we could do the same thing. We could say alert, hi, 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 hi. Hit Enter, and it alerts for us. We could also, because we're right in the console, we could log to this console. Hello from Caleb. And it says hello from Caleb, and it runs from this particular file, iframe console runner. That's just where I right-clicked and then went to inspect. And then it just runs this code for me. And what it returns is undefined because it's not returning anything. It's just printing something out for us. So whenever you see undefined, for the most part, you can just simply ignore that. We're going to see a lot of these when we work in the console. But for now, I would like you to try writing alert, hi, 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 and then console.log, hello from Caleb. Make sure you do it in your console or inside of CodePen as well. Last but not least, the way I got this to dark mode was, if I go into my settings, theme, light or dark. I like dark mode. I think it's a little easier on my eyes. It probably isn't, it probably doesn't matter, but I like dark mode anyways. And so that's why mine is dark and yours probably starts off in a lighter shade. Go ahead, give that a shot, and when you are done, we will move on to our next lesson, where we learn what JavaScript is, what it actually is. All right, let's take a look at what JavaScript actually is. What is JavaScript? Now, JavaScript is actually the only real programming language used in front-end web development. So when you're making a website, such as CodePen, like what you see in front of us, this is all front-end stuff. We see HTML, CSS, and JavaScript. We can't see the Python, we can't see PHP, we can't see Java, we can't see C, we can't see any of these other programming languages. We can only see HTML, CSS, and JavaScript. And out of those three, JavaScript is the only real programming language. Now, one of the reasons that JavaScript is so dang popular these days is because, again, your browser only supports these three markups and languages, HTML, CSS, and JavaScript. There are absolutely no other programming languages available for front-end web development. They just don't exist. If you want a programming language for your website, you have to use JavaScript. That is why it is so popular. It's the only option. Now, what really is JavaScript? JavaScript is anytime you click something, something else happens. So let's just go ahead and close that. When I click this, we can see that this little menu pops up. Or when I click change view, we can see this little menu pops up, fades in, fades out. Same thing over here. We can see all these different things. That is all JavaScript. It's interactivity. It's when I click and I drag like this. That is JavaScript. This is JavaScript. It even says CSS. That's where I'm supposed to write my CSS. But it is actually JavaScript that allows me to do this on the page. Same thing with the console. Same thing with toggling the console on and off or doing this. That is JavaScript that allows me to drag and drop things. It allows me to have that level of interactivity. So anytime you click something and the page changes, or you type somewhere, or you drag and drop, that's JavaScript. Think about it this way. Anytime something happens automatically, or automagically, as I like to call it, that's JavaScript at play. For the most part, that's going to be JavaScript. There are the odd cases where it's a hack done with CSS, but honestly, 99.9% of the time, all interactivity is done with JavaScript. So when someone asks you, hey, what is JavaScript? You can say, JavaScript is what makes your site interactive and makes your website feel like an app. Next up, let's talk about text editors. If you don't have one, we're going to get started with one right away. You need a text editor. In this lesson, we're going to get you set up with a text editor if you don't have one already. Now, this is very, very simple, and honestly, if you're writing JavaScript, you should already have a text editor because you should know a little bit of HTML or a little bit of CSS. If you don't know HTML or CSS, please check out my HTML 101, 201 courses, or my CSS 101, 201, or 301 courses. I cover all of these in depth. And you're going to need to know these in order to work with JavaScript. Now, let's go ahead and move off of CodePen, and let's go ahead and download a text editor. I'm just going to type in download VS Code. Yep, leave. That's just from the last lesson. I can get rid of this developer tools in here. And I'm just using Google Chrome as my browser. It doesn't really matter which browser you use. Let's go ahead and click this. And if you're on Windows, download the Windows. If you're on Linux, download the right Linux one for you. If you are on Mac, download Mac. In this course, it does not matter what operating system you use. We're going to be writing JavaScript, and it works the same way across every operating system. Once you have that downloaded, make sure you install it. And once it's installed, make sure you open up VS Code. And it should look something like this. No. Something like this. Now, mine is a slightly different theme than yours. Yours is going to look, I believe it's a little more brown. I like mine a little bit more blue. It looks better in these videos for you. So there's higher contrast ratios. You can see things a little nicer. But effectively, this is the exact same program that you're going to have. Yours just has different coloring. Now, if you're wondering, hey, Caleb, I really like yours. How do I make my VS Code look like yours? I get this question probably a dozen times a day. You can go into View, Extensions, and that just opens up this extension area. And in your search, if you type Material, and I'll just make that bigger, type in Material, you'll see Material Theme. I'm using Material Theme 30, not 33. Go ahead and you can install that, and then you can set. So then you can go to Set Color Theme, and you can have all these different ones in here. And you can see little previews if you just hit the down arrow. And the one I like to use is Material Theme Ocean High Contrast. High contrast, just makes it a little darker. That's very bright, but high contrast. This is the one that I use. So if you want your VS Code to look exactly like mine, I'm using Material Theme with which color theme in here? I am using Material Theme Ocean High Contrast. So go ahead, get VS Code downloaded, installed. Feel free to do this extra stuff if you want to, if you're totally happy with how it looks, the way it looks when you install it. Don't feel like you have to install this theme. I just know a lot of people are going to ask, so I'm Jumping the gun, I'm getting a little bit ahead of that curve. Once you have VS Code installed, let's head on over to that next lesson where we learn about our own personal coding playgrounds. All right, let's talk about our own personal coding playgrounds. Often you will see me write code in 3 different places just to tinker and figure things out, to experiment. One is going to be CodePen. We saw that already. That was in the very first lesson, maybe the second lesson, but it was just in codepen.io. And if I open my browser, I can actually go back to codepen.io, and it's just a brand new pen, and you can write HTML, CSS, and JavaScript in there. The second option is going to be if I just go to, for example, my website, caleb.io, right-click, inspect, and we'll bring this up. There's elements, console, sources, network, performance, memory, application, lighthouse, security, etc., etc. Go to console. And I'm just on any page. You can see my favicon actually doesn't exist. It's showing me an error. This is really good. It's actually a great example. An accidental example, but a great example. This is showing me that I don't have a favicon. It's responding with a 404, missing image or missing resource. But in here, I could say console.log, hello. And it shows up with hello. I could do console.error, uh-oh. And it says, uh-oh. Now, that's the second place. So the second place is going to be right in the console, and that's right on the page. It gives you access to all the JavaScript that could be written in place number 3, which is in VS Code. In VS Code, you can write a brand new either .js file, or you can write JavaScript inside of a script. We'll talk more about this in just a little bit, but there's 2 places inside of VS Code or inside of your editor where you can write your JavaScript. So you're going to see me write JavaScript in one of these 3 places throughout this course. That is A-okay, it doesn't really matter which one. They're all sort of the same. If you just want something nice and quick, I like to use CodePen. Just hop on CodePen, click New Pen. You can write your HTML, CSS, and JavaScript immediately. You don't have to worry about editors or writing your code and then loading it up in your browser, things like that. It just sort of does all that extra work for you. Next up, let's talk about JavaScript syntax. What does it look like? And we're going to get a brief overview of what it looks like, and we're going to dive into some complex things right away. Don't worry, I'm not going to get you to actually do any of the complex things right away. We're just going to talk about some of the JavaScript syntax, how it looks when we write it. All right, welcome back. Let's talk about JavaScript syntax, and that is how we write JavaScript, how it looks when we write it. So I have VS Code open here. Just go to File, New File, and then File, Save As, and I saved mine as index.html. Now in here at the bottom right, mine goes to a Django template by default. Yours probably goes straight to an HTML file. And I'm going to use an Emmet abbreviation here. I'm going to type HTML:5. You see this Emmet abbreviation in VS Code. Go ahead, slam that tab key, and that's going to print out all this junk for you. Now we learned about this in HTML and CSS. If you're unfamiliar with what this is, it's probably time to go back to HTML and CSS 101, HTML 101, CSS 101. We talk about this quite a bit. So JavaScript syntax, there's 2 places, actually there's 3 places we can write JavaScript. One is in the head and using the script tag, and then we can write some stuff in here. Or we can take this whole thing, copy it, and throw it inside of the body. Now there's 2 places inside the body we can put it. We can put it either at the top, somewhere in the middle, or near the bottom. And the best place is always just above this closing body tag. Now we put that in here at the very bottom and not up here because our page is going to load from top to bottom. So it's going to say line 1, okay, it's HTML. Line 2, HTML, English is the language. Line 3 is a head node, and inside of this node we have a meta node, another meta node, a title node, and a script node. Now if this script is referencing any of the elements that could be in the body and it gets loaded before the body does, which is rare, but it can happen, then it might not work the way you expect it to work. So let's get rid of that. And let's say there's a bunch of HTML in here. Blah, 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 blah. This looks terrible, but let's pretend that we wrote some good HTML in there. And then, so your browser goes, okay, load this aside, load this data grid, load this aside, load this data grid, close that side, yada, yada, yada. Then at the very end, we've got a script, and then maybe that JavaScript is accessing this aside. Well, this has now loaded because programs load things from top to bottom. It's already loaded. So we put it down here to make sure that our document object model has been as loaded as humanly possible. Let's go ahead and get rid of that, clean that up, and let's talk about what we can put in here. So there's two ways to do this. We can do an src, and we could say javascript.js, and this is just like in CSS when we link a CSS file to an HTML file, we are linking a JavaScript file to this HTML file. And so javascript.js needs to be an external file in the same folder as index.html. So that's one option, and we can use an external file for that, or we can write internal JavaScript, and we can just write it in here. Now, in here, there are a couple rules. No HTML. I see this all the time. Do not write HTML between your script tags. No HTML. There's no CSS whatsoever. Do not write HTML inside of your script tag. I see this a lot as well. People think if I write HTML and CSS in here, that JavaScript's just going to pick up on it and it's going to work. No, JavaScript is its own programming language. Everything between this opening tag and this closing tag needs to be pure JavaScript. Not HTML, not CSS, not Python, nothing else, just JavaScript. In here we can have things like variables, conditions, functions, and a few bits and bobs in between, like iterative syntax. So let's take a look quickly at what a lot of these look like. Now this is going to go really fast. Don't feel any pressure to memorize this at the moment. Each one of these concepts is going to have its own video or series of videos. So what I'm about to write, don't feel like you need to memorize this. Don't feel overwhelmed. Just know that I'm going really fast and it's okay. In the next few lessons, we're going to learn about all of this stuff. So we can declare a variable with var. Var is equal to name, and that name is equal to Caleb. This is a variable. We can also say if, as a conditional, if that name is equal to Caleb, we could say, hello, teacher. We could also say, hello, follow me on Insta at coding.for.everybody. And that's just where I post a bunch of tips and tricks for, well, web development, such as JavaScript. Let's go ahead and throw a semicolon at the end of each of those. So that's a conditional. We can do a function, so we can write function, greeting, name, that's a parameter, return, hello, name, welcome to the world of JavaScript. And that's a function, and then we can execute that function. I'll just scroll that up so you can see that. I'll just execute that function as greeting, or let's not call it greeting, let's call it a new function, const, so this cannot change. This is a different type of variable. We'll talk about this as well. Const greet is equal to greeting Caleb. Now at this point you should honestly be looking at this and going, I don't know what this is. You should be scratching your head, not understanding what this is. If you are doing that, you are in the right place at the right time. Do not worry about learning variables or conditionals or functions or consts and things like that. We're going to tackle all sorts of things in this course, including significantly more than just these concepts. But what I wanted to do was show you what this looks like right out of the box. So you could look at this and say, yep, that's a variable. Even if you don't fully understand all the different symbols in it, that's totally okay. It's good to be exposed to some of this stuff a little bit early. And you might be thinking, what's the difference between one equal sign and two equal signs? Or why put it in a function if we're just going to write something like that? Why not just put it in an alert or a console log like we have before? We're going to tackle all of these things in their own individual lessons. But this is JavaScript syntax in a nutshell. We have a variable. Some sort of name is equal to some sort of value. So we've got property, value, semicolon. If, then a parentheses, an opening parentheses, or an opening bracket, name, so that same variable, is equal to, double equal sign, Caleb. Again, we close it, that's our conditional. Execute a bunch of this code, and we tell it to execute that code with curly braces. So opening that curly brace says execute all this code if that name is equal to Caleb, and execute it up until here. Function is very similar. We're saying, hey, declare that this is a function. We can reuse a function over and over again. We called it greeting, so we can access it down here. Takes a parameter. That parameter is name. And that parameter goes between parentheses, goes between these opening and closing parentheses. And then we say execute all the code between these curly braces as well. So anything after this and anything before this, execute all that code. And then lastly, we said const, that is a variable that cannot change, so it's not actually a variable. If it can't change, what's the point of calling it a variable? But that's neither here nor there. We have a non-changing variable called greet. We executed the function and put a parameter named Caleb in here, and that's going to inject it right there. So it's going to say, hello Caleb, welcome to JavaScript. Now that was a lot. Again, don't feel like you need to memorize any of that. Don't feel like you need to understand any of that. In fact, if I said a bunch of things and you didn't understand what I was saying, you're in the right place. Don't worry. We're going to tackle all of these things one by one in a much slower manner. But again, I just wanted to show you that this is how JavaScript syntax typically looks. For now, what I would like you to do is actually just try and remember this. Var, some sort of name, some sort of value of some kind. It doesn't have to be name. It could be Caleb, it could be pet, could be computer, could be lamp, is equal to, just a single equal sign, quotation, then some sort of value, ending quotation, and then a semicolon. So just try to remember how this line looks. If you can remember this one line, you're going to do really, really well. Up next, we're going to talk about console logging. We've seen a little bit about this, and we've seen a little bit of this rather, and we are going to work a little bit more with console log right in an index.html file. All right, welcome back. Let's talk about console logging. In the last lesson, we looked at JavaScript syntax. It was a big, scary lesson. There was a lot of stuff you probably didn't understand. That is a-okay. You do not need to understand all of it right now. We're going to get to it piece by piece. For now, we need to learn about console log, and we've seen this a little bit. So what I would like to do is create a new HTML file. So I've called this index.html. I have an opening script tag and a closing script tag underneath my body. So it's just above this /body tag, the closing body tag. And in here, we can write all sorts of JavaScript. And one of the most common things you're going to see is this thing called console.log. And that allows us to write anything in here. Now, if I save this, and I do file, open file, and I click index.html and open this up, we're going to see that nothing happens on the page, but in the console, it says write anything in here. Now, how you get here is you just right-click on the page, go to inspect, and it's going to open up elements by default. Don't worry about that. Let's just head on over to console, and this is where your console is going to output your code. Or in this case, just the sentence that we wrote. Now, it doesn't just have to be console.log. We can also do console.warn. This is a warning. We can also do console.error. This is an error. Now, what we're saying here is access the console. That's this whole area. And this first one is saying log. Just simply write a message. Just log it out there. The second one is saying access that console. Then let's, instead of logging, let's produce a warning. So it's slightly different text. I'll show you what that looks like in a second. And then we've got opening and closing quotation marks, and then a bunch of words inside of here, just like we did with the first one. And both of these, all three of these, end in a semicolon. That tells the computer, hey, this function here, this piece of code to execute is done. Go on to the second one. And then it gets to this one, this semicolon says, hey, this one is done, move on to that next one. And lastly, that next one is accessing that console. It's saying instead of log or warn, write some sort of error. That's going to give us red text. Again, same thing, we have our opening and closing quotation marks, and then a bunch of words, a regular sentence. We have our opening and closing parentheses, and then a closing semicolon. Let's go ahead and save that. Let's go back to our page and hit refresh. And we see write anything here. That's what our log was. This is our warning. We can see it is a warning indeed. And in here we can see this one is an error. This is an error. This tells us exactly what's happening and where it's happening. Index.html on line 12. If I click that, shows up right here. Goes to sources, index.html for us. That's pretty wild. We could also do the same thing. This is an error. Index.html on line 13. And it goes straight to the source code for us. So that is super, super useful, very helpful stuff right there. If you're ever wondering where to get the log, same thing. Write anything in here comes from index.html on line 11, and I click it and it brings me to here. Again, I'm just using Google Chrome, but you can do this on Safari or Firefox or Edge. You might not have the right-click inspect feature. On Safari, you might have to go and enable that in your settings. You can either enable that in your settings or just open this up in Chrome and go to File Inspect, or open it up in Firefox, not File Inspect, but just right-click Inspect. Or you can always go to View, Developer, and Developer Tools. And oops, that actually toggled it off because it was already on. Developer Tools, there we go, brings that back. And then I just go to Console. And that is console logging in a nutshell. Next up, let's debug external files. So let's create a JavaScript file that lives outside of our document, and let's see what happens when we have a typo. And if it doesn't work for you, how do we debug this? Debugging external files. In this lesson, we're going to take a look at how we can figure out if there is, well, a file that is actually loading properly or not. So carrying on from that last lesson, let's go ahead and get rid of all of this, and let's create a new JavaScript file, and we're going to call this script.js. Now this looks a lot like in HTML. We've got link, and href is like, it's going to go to style.css, and that's going to go to an external style.css file. JavaScript has the same functionality, but we use the script tag, the src attribute, and then we tend to call it script or app.js. And we don't put anything in here. Then we have a closing script tag, and that simply says we are going to be loading some external JavaScript. So let's go ahead and save this, create a new file, and save that as script.js. And let's, if we do this right, console.log page successfully loaded script.js. Now, if we refresh our page, this should, in our console.log, say page successfully loaded script.js. Now I'm going to refresh this page, and it says page successfully loaded script.js. Now let's talk about if this does not work for you. And a lot of people get stuck here, and this has to do with pathing. We looked at this in HTML images in HTML 101. We looked at this in CSS 101 and CSS 201 with background images. Let's say you didn't call it script. Let's say you called it scrpt. You forgot the letter I. Let's go ahead and save that and start over as if we were starting fresh. Reload our page. Looks like nothing happens. Right click, inspect. We're going to go over to our console, and it says failed to load resource, error, file not found, scrpt.js. Now if you're looking at this and you're like, well, I don't know what's going on, it's because it literally cannot find your file. And that almost 100% of the time means you either have a typo or a pathing issue. That means you've tried to do something, which would be like the folder name, and then script.js, and it doesn't access the folder properly, it doesn't know how. Again, probably a typo, might be missing the slash in front. It really depends on how you're pathing that. Or, in our example, we simply forgot the letter I. And so if we fix that, come back to our page and refresh, page successfully loaded, script.js. So that is how you debug your external files using JavaScript, or how you debug your JavaScript external files. Please, please, please keep this in mind, because you're going to run into this a lot in the future. In the next lesson, we're going to take a look at storing data with variables. Storing data with variables. There are lots of different types of variables, but we're going to get started with the most common and simplest form, a string, and we've actually been using these already. So what I have here is just from that last lesson. I've got a regular HTML document here, nothing fancy. I have a script tag accessing the source of script.js. That's this file that also exists. This is using an external JavaScript file, and it simply closes that tag, and we can write JavaScript in here. Now in here, we don't need to write script. We don't write any HTML at all. It's just straight JavaScript. And what we can do here is we can create a new variable. So let's create a new variable called var. Website is equal to https codingforeverybody.com. This could be a variable. We could also declare another variable name. Let's do teacher name, and you see it's camel cased here, so little t, Capital N, that is a common way to name variables in JavaScript. Teacher name is Caleb Tallien. That is me. I am Caleb Tallien, your coding teacher. And in here we could say console.log, and what we've been doing so far is if I write my own name in here, it looks exactly like this. In fact, if I highlight it, it highlights in two places. It shows me that it's the exact same. Now, because this is a variable, I can delete that and write teacher name. And what this is going to do is say, access this variable that's defined here. This variable is equal to Caleb Tallien. So it goes from here to here to here. Now, at this point, you're probably thinking, well, why would I do that when I could just write this out? What if you wanted to console log a bunch of times? You would have to select all of these, and you'd have to write Caleb Tallien. One by one by one by one by one by one by one. And that's going to be very, very painful. And then what happens? What happens if I change that name to Caleb Tallien 2? Well, then I got to go here, 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 here. And it's painful. And we don't want to do that. So we can use instead, just undo all of that, teacher name. Now, if you're just coming to JavaScript, you're just entering this course now, and you just saw me do a bunch of wizardry. First of all, let's go ahead and delete these lines. What I did here was I Command C, Command V, or Control C, Control V, and that just copied the whole line. Now to select the next occurrence, what I did was I double-clicked on teacher name, and I went to View. Nope, maybe Selection. Add next occurrence. Selection, add next occurrence. Selection, add next occurrence. That shortcut is Command D for me, probably Control D for you if you're on Windows, and then anything else in here. And then Command Z or Control Z to undo. That's all I did there. So it's good to know how your editor works, but I know a lot of people are going to ask about that. I get this question dozens of times a day, so I figured I would throw that in this lesson anyways. Now, if we look at the syntax for a variable, we have var, stands for variable. Then we have some sort of name. We do not put special characters in here, so don't write #, hashtag. Keep it simple. Just call it hashtag if you need to, or website. Typically, we do not capitalize the first letter. This means something else in different programming languages. This usually means it's a class, not a variable. We'll talk about that way down the road, but for now, keep it lowercase. If you have multiple words in one variable, one thing you'll see in different programming languages is underscores. So it'll all be lowercase, and then it'll say teacher underscore name. And in JavaScript, sure, we can do that, but we tend to do JavaScript. The JavaScript way is lowercase t for teacher, and then every word after that is capitalized with the first letter being capitalized. Then we say is equal to, and that is one single equal sign. This is the assignment operator, and that means teacher name here and website are variables. So your computer is going to go off and reserve a little piece of memory for both of those. And in the first one, it's going to grab all of this. This is your string. And it's going to jam it inside of the website piece of memory that your computer's allocated. This is a string as well. This has an opening quotation, a closing quotation. And inside of it, we can have spaces, we can have numbers, we can have letters, we can have anything we want in here. It doesn't matter. Whoa, I went way too far there. But we can have anything we want in here. And that makes it a string because it's got an opening and a closing quotation. Alternatively, instead of using quotations, we can use apostrophes as well. As long as it opens and closes with the same thing, that's all that really matters. So this is a string. And that's saying this string, this sentence, is now going to belong in this piece of memory called teacher name. That's the short name. That's how we access this piece of memory in your computer. And then we can access that piece of memory by its short name and then access whatever is in that piece of memory. Now, if I lost you in the computer science part, that is a-okay. All you need to remember is variable. Something is equal to quotations, something else, semicolon. That is a string. And in fact, this is the string part of it. And if I go ahead and change this to website, let's go ahead and refresh our page here, and we can see that it shows up with codingforeverybody.com. Next up, let's talk about two new variable types found in modern JavaScript. We're going to skip ahead about 25 years into modern JavaScript. Let and const. Let and const are two new variable types in JavaScript. These are performance-based variables and come with this thing called scoping, which we'll talk about significantly down the road. So really, to learn about let and const, we have to pretend we know about some other things. So what I'm saying here is let and const, and it's just like how in that last lesson, how I wrote var, short for variable, and then something is equal to something else. Let and const work the same way. The difference is these are scoped to their closest set of curly braces, which actually makes them significantly more performant. So in JavaScript, as soon as you write a variable up here, you can write it and access it anywhere else. Let and const don't let you do that. So as an example, let, I have number of apples is equal to 1. I've got 1 apple right now. Const, this stands for a constant. A constant cannot be reassigned. And so we're going to eventually reassign apples so that there's 2, 3, 4, 5, 6 apples. But const, we cannot change that. What is something we cannot change? Height. My height is going to be 6 foot 0 inches. And here's, this is actually a great example. This showed up on accident. Is 6 foot 0? This is going to err on me because there's 3 quotations in here. Or quotation marks. I can't use apostrophes because there's an apostrophe in the middle too. So this is going to get really messy. What we can do is this thing called escaping. So I can say 6 apostrophe 0 and then the quotation, but in front of it, I put a slash. And that says, hey, computer who's interpreting this JavaScript, just know that this is supposed to be an actual quotation mark. This is not supposed to actually close the string. So now we can put it inside there. So there we go. Fun little fact there. And let's go ahead and save this. Let's go back here and refresh the page, and that just logs the website from our last lesson. And the variable we named here was apples. So in our console, we can do apples. And that gives us 1. We can reassign this and we can say that there are now 4 apples. And when we type apples, it gives us 4. Now we have a constant here, a constant. We're going to go with my height. And so let's type in height. Height is 6 foot 0. Let's go ahead and change that height to anything else. Literally anything else. It does not matter what it is. And we're going to see an error. And this error is an uncaught type error. Assignment to constant variable. That means we cannot reassign this. And so now we're talking about variable types. We've got var, which is the old school way of writing JavaScript, and let and const. Let is like a variable that you can write over and over and over again. You can reuse that name. Once const is declared, as in height is equal to any value, we cannot declare it, or not redeclare it, but we cannot overwrite it. We need to make sure that this stays the same all the time. Now the difference between let and const versus var is we could say if teacher name, and this is getting into a conditional, we'll talk about these in a little bit, so you don't need to know too much about this at the moment. So if the teacher name is equal to, so we're comparing this, Caleb Tallien, and you can see that it does, it matches perfectly up here. Then, opening curly brace, closing curly brace, do a thing. And so let's go ahead and assign this. So if the teacher is Caleb Tallien, assign these. And what we want to do is then console.log, and we can say, I have how many apples? Apples. Apples. And this is just going to say, I have apples, apples. So I have 1 apples. I have, let's change this to 5. I have 5 apples. And you can actually see my editor is already complaining. It's saying, basically, this is not used. Apples is declared, but its value is never read. And that's because it is scoped to this area. That means it cannot escape this area. Let's go ahead and give this a shot. And I'm going to show you what this looks like. Apples is not defined. We did define it though. It's here. If we just simply move this up, this console log into where apples is scoped, where it can live between these curly braces, this will work. It says I have 5 apples. But again, if I move that back down, I have 5 apples. Another one could say console.log I am, and then height. I am, not I have. And these semicolons, I like to put them there. They are optional though. Let's go ahead and save that. Refresh, we're going to see, again, apples is not defined. Okay, well let's move that up to where it is defined, where it's allowed to live within these curly braces. And again, remember, variable does not have this sort of protection around it. Variable we can use anywhere. We can use website in here or in here. It does not matter. It does not care. It is not performant that way. Whereas let and const say, yes, it has to exist in here. So let's go ahead and move I have apples into, well, where apples lives. And refresh. And this says height is not defined. That's coming from line 11 here. And we can see that script.js on line 11, it says height is not defined. So if you ever run into this issue where you have clearly defined a variable using let or const, but it's not working, chances are it's just not allowed to leave its closest set of curly braces. Now, to prove that var is allowed to live anywhere, we can do this. Var height is equal to, and when I refresh this page, go to the console, we're not going to see this error. Let's go ahead and refresh, and I am 6'0". Const does not let me do that. I can actually move apples down as well. Apples is not defined, but if I do var and var, it shows up again. So what's important to note is moving forward, we are going to be using let and const quite a bit. I may occasionally use var, but probably just let and const, and that's going to be scoped to the closest set of curly braces, which means it can only live within its closest set of curly braces. Now it doesn't need curly braces. They can live without the curly braces. Let's go ahead and save this just as an example. And this works every time I hit refresh. So moving forward, I'm going to try to use let and const. Let means it can be rewritten. Const means it is a constant. It can only have one constant value. It can never be changed. In the next lesson, let's go ahead and write some code notes or code comments, meaning we can add little notes in here. We can comment things out, as in we can make sure that this is not applied to our code. We're going to do that in the next lesson. Writing code notes with code comments. Code comments let us write notes in our code without the browser trying to execute the code. Now, this is just leaving off from that last lesson, and what I'm going to do is just get rid of that conditional because we haven't learned about those yet, and I don't want to bombard you with information that we haven't learned about yet. Now, if I save this, go back to my page and hit refresh, I have 5 apples, I am 6'0", and a website, codingforeverybody.com. What I can do is, let's say I don't want to show I have the number of apples and I don't want to show my height. I can delete that code, and when I refresh the page, it doesn't show up. That's perfect. What if I wanted to bring that back? Well, there's 2 ways to do this. Is you can hit Control-Z or Command-Z, or go to Edit, Undo, and that will bring it back. What if I didn't want to delete it, I just wanted to make sure that it doesn't execute the way we think it's going to execute? What I can do is hit Command plus slash or Control slash, and that's going to simply comment this out for me. Now that shortcut might be different for you, and if it is different for you, that's okay. What we can do is we can add a code comment with 2 slashes. So we can write // and that gets rid of this. // gets rid of all of that. And so you can see it goes gray, and that basically means the code is still here, it still lives here. But the program that's going to execute our JavaScript is not actually going to execute this. Let's go ahead and refresh, and we can see that nothing happens, but we're also not getting any errors, so that's good news. Now that's how we comment out a single line, but there's another way to do this. We can comment out multiple lines by doing slash and then an asterisk, and go down here, and this will be commented until told otherwise. And so this is just going to comment all of our code from line 6 all the way down to the bottom of our script. So if we have 1,000 lines, that just commented out line 6 to 1000, meaning that's no longer going to work for you. To make sure that comment stops, we do asterisk and then a slash. And then here we can do console.warn hello world. And that's going to work for us again. So all we've done here is we've commented out all of these lines with one multi-line comment. And if I go ahead and get rid of this, you can see that things start to become colorful again in my text editor. And we can do // or we can do even on the same line, something like that. Now this is going to say I am height. Height is not applied. This is going to give us an error. As expected, height is not defined because this is referencing a variable that simply doesn't exist. It exists to us because we can read it, but the program, the JavaScript program itself, is saying, oh, well, this is a bunch of code comments. I don't need to execute any of this. So just pretend it doesn't exist. So we say const height is equal to, let's say 6 foot 0, and because it's in a code comment, it's simply not going to work. So what I would like you to do for this particular lesson is I would like you to write, I don't know, like 4 lines of code, do a single line comment, and then try a multi-line comment. Something like this, a multi-line comment. It ends with that, starts with that, and a single line comment starts with //. Oh, one more thing. We can also do comments at the end of lines. We can do //. This is at the end of the line. This is at the end of the line. And so it doesn't change the syntax highlighting, the coloring of my code here, because this is only applying the comment afterwards. So one thing to keep in mind there is it'll only comment things after the //. Go ahead, give that a shot, write yourself a nice little note. When you are ready, we'll head on over to that next lesson where we talk about operators. So things like where we have seen website is equal to, we're going to look at that operator. We're going to look at other operators as well. There's a handful of them. They're all very, very easy and for the most part straightforward, but they are worth going over for sure. So in the next lesson, let's talk about that. Operators. Hello, operator. Are you there? Hello, hello. So I'm just going to delete all the stuff that we have been writing so far. If you've been writing with me, you can delete all of your stuff or just comment it out and you can use it as a reference for later. In this lesson, we're going to talk about operators. So operators are ways to work with variables. So we can say const name is equal to Caleb Tallien and let profession is equal to, let's say, programmer. I'm a programmer. I'm also a teacher. We might maybe overwrite this. I'm not sure. We want to make sure this is changeable, but you know what? My name is never going to change. So I will always be Caleb Tallien. And so what we're doing here is we are using the assignment operator. We're saying variable, the constant, name is equal to Caleb Tallien. Let, the variable type, profession, that's the name, is equal to, this is an assignment operator, programmer. And these are strings. This is a string, and this is a string. But there are lots of other ones as well. So let's go ahead and save this, and let's just open up Google Chrome and right-click, inspect, and let's go to our console, and let's write some code in our console here. So I'm going to make this just a tad bigger for anyone who's watching on their mobile devices. And so let's go ahead and create a new variable. Let's say let num is equal to 10. Num is equal to 10. What if we wanted to add to it? We could say num is equal to num plus another 10, and this is going to now be 20. So now we're saying, hey, allocate a new piece of memory in our computer, use the current one, that's 10 plus 10, and this is going to give us 20, just like we see here, 20. Go ahead, we can clear this. We can also say something like 10 plus 20 is going to give us 30. This is the addition operator. Now subtraction, very, very similar. We could do 23 minus 12 gives us 11. Or we could say the total const. No, let's do let because we might overwrite it. Total is equal to 23 minus 12. And the total is 11. So now we've stored that in a variable that we can overwrite down the road. That's subtraction. We also have division. Let's clear this out. We also have division. So we could do like 100 divided by 10 is 10, or 99 divided by 11 is 9, or 99 divided by 87. 1.137931034482758, obviously. So that's division. Let's go ahead and do multiplication. Multiplication is, nope, not that sign. This one, your little asterisk. So we could do, let's say 3 times 3, that's going to give us 9. Now those are the 4 basic math operators. We have a few more interesting ones in here. We have exponents. So 3 to the exponent of 3 is going to be 3 times 3 times 3. This is going to give us 27. We also have modulus, aka remainder. So when you divide by a number and there's a remainder, what is that going to be? So when we do 10 divided by 3, what is that remainder going to be? So it goes 369, so it goes in 3 times with a remainder of 1. 10 modulus 3 gives us a remainder of 1. There's also 2 more I want to go over, increment and decrement. So what do we currently have assigned? Total? Total is 11. We could say total plus plus. And what this is going to do is give us the exact same value. But what it actually did was it returned 11, and it said, when you're done returning 11, add 1 more to it. Total is now 12. We can do the opposite. We can say plus plus total, and instead of this returning the current number, it's going to add to the number and then return it. So now we're saying 12 is now 13, and this again will be 13 all the way. Versus total plus plus, again this is going to say 13, but if we access it once more, it becomes 14. So that is increment by 1. We use plus plus. Now if we want to do the same thing, but opposite, same but different, let's see what total is. Total is 14. We can say total minus minus, and that's going to give us, again, 14. But if we do total once more, what this did was say, hey, give us the current value and then minus 1. So this is now going to be 13. And this gets a little bit weird, because if we do minus minus total, the current value was 13. It's now going to say 12 as we currently expect. And if we write it once more, it's going to stay as 12. So it's just the order of operations that happens behind the scenes. Honestly, you don't need to remember that too much at this point in time. The big ones you're going to want to remember are equals, division, multiplication, addition, subtraction, and occasionally modulus. Maybe exponents as well, maybe. These ones you're not going to use too often. Like, you don't really need to know them like a professional right now, but I would say remember these ones. So you've got, in this order, equals, that's assignment, division, multiplication, addition, subtraction, modulus, exponents. Increment by 1, decrement by 1. In the next lesson, let's talk about different types of variables, aka data, structures, and this is actually not very hard at all. This is somewhat of a buzzword. People like data structures. It's all part of algorithms. It's really just different data types. Nothing fancy about it. Don't get too excited. It's just different types of variables. We'll talk about these in the next lesson. Let's talk about different types of variables. Data structures. Okay, so a lot of people say, oh, you need to know these data structures for algorithms, which is not wrong, but you actually don't need to know it just for algorithms. You should know them for several other reasons. It makes comparing things easier. And at this point in time, you're probably like, well, Caleb, what does that even mean? We're going to get into that in this lesson. So JavaScript, like most programming languages, has a lot of different types of variables. We've seen var, let, and const. These declare how the variables actually work behind the scenes, but we are working with the variable itself, the piece of memory in your computer. There are different things we have learned about strings, which have quotations around them. They're basically sentences. So we could say const str is equal to a string. A string. We could also say const, and we can give some sort of number. num is equal to, let's say 3. And this is a number. Notice there are no quotation marks around it. If there are no quotations around it, this is a number. This is a number. And this is a string. Next we have a thing called a float, an FLT. That's a 3.14. And this is called a float. And a float is when you have a decimal in there because it's like a floating decimal point. So this is going to assume 3.00, and that's going to round up to 3 as a whole number. A float is going to be 3 point something that's not 00, 3.14 for example. Then we have a Boolean, and this is either going to be true or false. True or false. And actually that's going to be or false. That's a better way to write it. So Boolean can only ever be true or false. Everything boils down to is something true, is something false in programming. Next we have an array, which is basically a list. And we have an array of items in here. We can have an array with a string, number, float, Boolean, another list inside of it. But this is called an array. So we could say item 1, 2, 3, 3.14, and another list. And this one looks a little interesting because this one starts with a hard bracket on the left, ends with a hard bracket on the right. Every item is separated with a comma and ideally a space right after that. So comma, 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 chameleon. And then we're going to call this an array, which really just means a list. But programmers like their fancy words for some reason, so we're going to call it an array. Const thing is equal to null. That simply means that there is a piece of memory allocated to this called thing, this variable called thing, but there's actually nothing in it, not even a 0. There's nothing in it. Has nothing in it. Const not defined is equal to undefined. And this one simply means that it's not defined. It means there could be something in it eventually, but currently there is nothing in it. So currently holds no value. There's another one in here. We could do const some sort of function. So we could say get age is equal to function. Conjunction junction, what's your function? Returning 31. Aw, I'm 31 already? Alright, well I guess I'm 31 now. So this is a function, and we can add a code comment here. This is a function. And this allows us to use getAge over and over and over and over again. We'll talk about functions down the road with their own series of videos as well. Last but not least, there is another one in here called objects. And objects look like this. They've got an opening and closing curly brace, and then some sort of key value pair. And this one has like name, Caleb, profession, coding teacher. And so this has an opening curly brace. This has some sort of key, and then some sort of value, and then a comma. And in between that key value is a colon, a full colon, not a semicolon, but a full colon. And then we can add another one. So that's a key, and this one is a value. And then we can access this. So this is called an object, and can be accessed with obj name. So it looks something like that. So these are a lot of the different data types that you're going to see in JavaScript. There's actually a few more that we're not going to get into because they're a little too advanced for us at this point in time, but we're going to see a lot of these. So what I would like you to do is, if you haven't already, pause the video here and take a screenshot. This is a really good little list of different data types in JavaScript. In fact, let's do this. JavaScript data types. There we go. Go ahead, pause the video and take a screenshot of this. This is going to be very, very useful as a reference down the road. There's also a couple other data types like big int or symbols, and again, we're not going to get into those just because they're a little too advanced for us at the moment. We might get into them a little down the road, but we should work with these first. And really all we've worked with so far are strings. And just a reminder, I'm using const here, so none of these can be reused whatsoever. These have to be set and forgotten. In the next lesson, let's go ahead and talk about conditional statements. We've taken a look at conditional statements before, but let's go ahead and actually learn about them this time. Conditional statements. Conditional statements let you take an action or ignore an action if a variable holds a certain value. So we've written things like this before. Const name is equal to Caleb Tallene. And in fact, what I can do instead is const Twitter at Caleb Tallene. If you ever want to follow me, you can follow me there. That is a good place to follow me, or on Instagram at Coding for Everybody if you wanted to. Conditional statements. Yeah, let's talk about these. So we have a constant. That means we cannot reassign this variable. This variable is called Twitter, and it has a value of Caleb Tallene. This is a string. So we can now say if, opening and closing parentheses, Twitter is equal to, and this is not an assignment. One equal sign is an assignment operator. That means this piece of text belongs to this variable. Two of them means it's checking to see if what's on the left compares to what's on the right and are the same thing. At Caleb Tallene. And we could then have an opening and closing curly brace. And that just means if this condition is true, if it is in fact accurate, if it is correct, execute the code in here. Execute this code in here. And we could say console.log Twitter handle is at Caleb Tallene. So we're not really reusing a variable at this point. We could be reusing this over here, but we're not going to, not yet anyways. And we just want to make sure that when we load this page up, that it console logs the way we expect. So let's go ahead and clear this. And this is just from last lesson. Let's go ahead and refresh. And it says Twitter handle is at Caleb Tallene. Now how I got that is on my index.html page, I've got script src is equal to script.js, and I'm writing all my JavaScript in a .js file. Now let's go ahead and type an else statement. What this means is if Twitter is equal to Caleb Tallene, cool, it's going to execute some stuff, but what if it's not? What if Twitter is equal to someone else? Let's say Elon Musk. I'm hoping that that's his Twitter handle and not some spam account. But we're now saying if Twitter is equal to Caleb Tallene. Now this is a lot like saying if at Elon Musk is equal to Caleb Tallene, then do a thing. Well, that's not right. Elon Musk and Caleb Tallene, these strings are different. It doesn't really matter what the value is. These strings are different. And so this is going to be false. Is Elon Musk the same as Caleb Tallene? No, it is not. So that is false. That is a lot like saying this is false. So it's not going to execute. It's always looking for a true. If it gets a false, nothing's going to happen here. So let's go ahead and change that back. We say if the variable, which is Elon Musk, so it goes from here to here to here, is equal to Caleb Tallene, execute this code. Now let's go ahead and refresh this page, and we're going to see that nothing happens. There's nothing in there. It doesn't matter how many times I refresh. Nothing happens. Else, execute this code if it's not at Caleb Tallene. And so what I'm saying here is if there is something else going on. So if the Twitter value here is anything else, it's not Caleb Tallene, it's anything else in the world, execute this. So we could say console.log Twitter is the Twitter handle. Let's go ahead and save. Let's go ahead and refresh. Elon Musk is the Twitter handle. And if I change this back to Caleb Tallene, Twitter handle is Caleb Tallene. Change it back to Elon Musk. Elon Musk is the Twitter handle. And so now we have some sort of way of telling a program what to do based on a value. Now, this is not a useful example. Let's go ahead and create a useful example. I'm going to make some room to work here. I'm going to say const my age is equal to, I'm going to pretend I'm 18. I can say if my age is equal to or greater than 18, console.log, I'm allowed to vote. And you should always vote, always exercise your right to vote. I can also say if age is greater than or equal to 21, and let's say I live in the United States. I don't, but let's say I live in the United States. I could say console.log I can drink alcohols. Let's go ahead and refresh this. Elon Musk is the Twitter handle. We can ignore that one. That's just from the previous example. I am allowed to vote shows up. This is being executed because age is 18 or older, greater than or equal to. This one doesn't show up because I'm not allowed to drink. I'm not old enough. So I could say else console.log not old enough to drink alcohols. And when I refresh, it says not old enough to drink alcohols. And so what this is effectively saying is if age 18 is greater than or equal to 21, it's not. That is wrong, and wrong things are false. This will never get executed because your conditionals are always looking for true. And we see that up here. We're seeing age 18 is not greater than, but it is equal to 18. And so this is accurate. This is true. This will get executed. Now we have a few different operators we can use. And what I would like you to do is give these a shot. I want you to go off and write some of these on your own as well. So just write a simple if statement. Something like if 18 is greater than or equal to 18, or actually age. So this is the full example. If age is equal to or greater than 18. But these are some of the comparison operators we have. Is equal to, is greater than or equal to, is less than or equal to, does not equal. So this is saying if the age does not equal something very specific, if the age does not equal something specific, or if the Twitter handle does not equal Caleb Tallien, this is going to execute. So give that a shot as well. Last but not least, I actually forgot a thing. So actually what I would like you to do is pause that video, give these a shot, and then when you are done, come back. I'm going to show you one more thing. All right, one more thing. Here is what we missed is an else if. So if the age is equal to 18 or higher, 18 or greater, then run something. Cool, cool, cool. We have if a comparison is equal to, one string is equal to another string. Cool, 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 cool. Let's go ahead and say if something is equal to something else, or something is equal to something else, or every other scenario. And we can do that quite easily with const name is equal to Caleb. We could say if name is equal to Nathan, console.log, welcome, Nathan. And then instead of saying else, if name is equal to Caleb, do something in here, we can say, let's go ahead and just bring this onto its own line, else if. Let's go ahead and get rid of that line and say console.log hello Caleb, and just outdent those. Let's go ahead and rerun this. Unexpected token. What did I do there? Oh, typo. It's else if, 2 words. There we go. It says hello Caleb. Let's just make sure that's right. Hello Caleb 123 123 123. Hello Caleb 123 123 123. And then we could say else console.log hello to a guest. Or a guest, hello guest. That actually makes a lot more sense in English. So now what we're saying here is if the name is equal to Nathan, write this out. Otherwise, if the name is equal to Caleb, write this out. And if the name is not Nathan or Caleb, and it's going to try Nathan first because it comes first, it's in order, so it's going to try Nathan first, then Caleb. If it doesn't match Nathan or Caleb, it's going to then say hell guest. Hello guest, that's better. Hello Caleb, let's change that name to John. It says hello guest. There we go. So those are conditionals in JavaScript. We have an if statement with a conditional equal equals. That is a comparison. We're comparing one string to another string here. We are comparing a number to another number here. This is why data structures are important. Data types are important. We have if condition, else if condition, and else condition. What I would like you to do now is go ahead and create an if statement, an else if statement, and an else statement. And then try to get each one of those to trigger on your own by changing the value of this one variable. Go ahead and give that a shot because this is a fundamental part of JavaScript. Without it, we cannot tell a program exactly what to do. So we need to know this fairly well before we continue. Go ahead, give that a shot. Don't forget to ask questions in the Learning to Code Facebook group. I'm happy to help at any given time. Once you've done that, let's head on over to that next lesson where we learn about the document object model. Hello and welcome back. Welcome to the document object model. So when a page is loaded, your browser uses all the HTML elements to create a tree hierarchy. And we can actually see this here in VS Code. When I go down here, we can see body HTML. If we indent this, we have an HTML element, we've got a head element, and then even here we've got meta head HTML. Meta head HTML. This is making sort of a sideways looking tree graph. We could get deeper and deeper and deeper too. So if we're writing regular HTML, we could have a div, paragraph, and a bold thing in here. And this is going to create our tree for us. It's got HTML, body, div, p, bold. HTML, body, div, p, bold. So this is an okay example, but what I'm going to try to do is look up an image for a document object model. And so this is the document object model. And what this is doing is saying we can collapse these. We can say HTML.head, HTML.body. And we can access these through their child nodes. All right, so I just typed into Google HTML DOM document object model. And I'm going to click this first one in here. Is this going to bring me anywhere? Hey, it brings me to W3 Schools. I haven't seen the site in a while. Can we get a better image though? All right, so this is an example of a document object model. We've got our document, which happens to be HTML. And then we've got either head or body. That's pretty standard across every web page. Then in our head, we either have a title with some text or meta with some attribute and some other text inside of it. In our body, we can then have other elements. We can have a table, paragraph, H2, all sorts of things in there. Inside of our H2, we could have, for example, the text that says, hi there. In our paragraph, we could say, you are all right. But inside of our table, we would have a TR for a table row, and then a TD, and then some sort of inner text. So this now gets into nesting. And so now to access this, we're looking at the HTML element, body element, table element, the TR element, the TD element, and then the inner text of that TD element, that table data cell. Now each one of these is called a node, and a node can have another node inside of it for the most part. Usually meta nodes don't, and most nodes inside the head don't actually. Image nodes don't because it's a self-closing tag, but a table, paragraph, and an H2 could have HTML elements inside of it. It could have a node inside of it. And so an example here is the table has a TR node inside of it. And then that has a TD node inside of it. So if we're talking about the TD element here, its parent is the TR element. And the TR element's parent is the table element. And if we go the other way, the table element's child is TR, and the TR's child element is TD. Now, when I say element, I'm using that interchangeably with the word node. Node and element are kind of the same thing. So if we go back to our code here and just uncollapse that, this would be an element and a node. It's a div element, but this node has all of this inside of it. Likewise, even though this is a smaller node, this is a smaller element, there's no child elements inside of it, this is still a node as well. And likewise, meta is a node, it's also an HTML element. This is an HTML element, it's also a node. And title is an HTML element with a node, or as a node rather. It just happens to be that it has inner text. So nodes are literally just HTML elements with attributes and inner content and sometimes some child nodes. So really, whenever you hear the word node, and you're going to hear this a lot, you're just talking about an HTML element in front-end JavaScript. That's all it is. This is a title node. This is a head node with all the stuff inside of it. This is a div node. This is a div node. This is a paragraph node. This is a bold node. So that is the document object model. Why is this important to know? Because eventually we're going to be selecting elements by their name, by their ID, by their classes, by all sorts of different things, and then we're going to modify them. And we're going to start to get into that in the next lesson, where we start looking at selecting one of these elements by its ID. All right, let's take a look at selecting an element by its ID. So what I'm going to do is I'm going to demonstrate how we can select an element by its ID and sort of what it does in the document object model. And this is going to allow us to grab the entire HTML element, or the node, and work with it in any way we really need to. So what I'm going to do in here is create an element called box, so number sign box. As soon as I see Emmet abbreviation, I can hit tab, and there's going to be a thing in here. That's all it's going to say. And in my script.js, I'm going to go ahead and clear that out so there's nothing in there. And what I can do is refresh this page, and it says a thing in here. If I make this bigger, I can right-click inspect. Ooh, make that just a touch smaller. So it says a thing in here, and we have this box. Now we can go ahead and grab this box. We can say in our console, const box is equal to document dot query. Nope, not query selector. That's a different one. We want get element by ID, and then that ID name, which is box. And that ID name just matches this one here. ID is equal to box. ID is equal to box. Let's go ahead and hit enter. It's going to say undefined, but if we type box again, that's going to give us, look at that. It's the entire HTML node. It's exactly what we wrote in VS Code in our editor. Now what's nice about this is we can do something like box.innerText is equal to something new. And it changes it. Changed it up here. Changed it right on our page. We could even do box.innerHTML is equal to something, and then new is bolded / strong. And then it says something new is bolded with new is bolded. And so that's how we get an element by its ID. And that's why, if you took HTML 101 or CSS 101, either of my courses there, I talk about IDs and how they're supposed to be unique. What happens if there's two of them on here? This is the second one. Now there's two IDs with box. Let's go ahead and refresh this page, and I'm going to click in here and just hit the up arrow till I get back to this code. Okay. And when I type box again, it gives me a thing in here. What if I didn't want the first one? What if I wanted the second one? How am I going to select that? I can't do it by my ID because there's two of the same ID. And that's why in HTML 101 and CSS 101, I was talking about IDs being completely unique. So make it box and box 2 if you need to. Make it box and box dash other if you need to. Now, just as a recap, we have box is equal to document dot get element by ID. Document is the entire document, like the document object model. Get element by ID, so go through all of the different nodes and find the one with the ID of box. Then, what I want is to use that box to change that inner text is just inner text. And remember, we capitalize the second word, not the first word in JavaScript variables. So box.innerText is equal to something else. Or we could do, if we wanted to add some HTML, we could do box.innerHTML is equal to something underscore else. And that just adds an underscore in there. And that actually changes our document object model as well. We can see the box in here. We have added a U element, an underline element. And so that is how we change the inner HTML of an element. That's how we change the inner text of an element. Remember, inner text does not hold HTML. Inner HTML only holds text and HTML as well. But inner text is just text, not HTML. So that's how we get an element by its ID. That's how we change its inner text. That's how we change its inner HTML. What I would like you to do as an experiment is I want you to Grab a node. I just called mine box because I don't know. I was going to originally make it a box and didn't. And then use document.getElement by ID and then grab it by its ID. And then do box.innerText is equal to and write some HTML in here and see what happens. Go ahead and give that a shot, and when you are done, we'll head on over to that next lesson where we talk about objects. All right, let's talk about objects. Objects are the objective. Objects are a way to make variable names inside of another variable. They come in a key value pair. We looked at this very briefly quite a while ago. The value can be pretty much anything. It can even be another object. And these are super useful when grouping variables together. So as a recap, we could have let person is equal to, and then this is an object. And if we ever wanted to make sure that it was an object, we could do type of, and then the variable name, and it says it's an object. Now we could change this. We could say person is equal to, and then just an opening curly brace, and the name is going to be me, Caleb. And my job is going to be teaching you JavaScript, and then a closing curly brace. And so this is the syntax here. We've got a variable name is equal to, and I've already defined it as a let, so I'm just using the variable name and not just let person, as in, I'm not writing let, I'm just writing person. It doesn't really matter at this point because it's already been declared up here. But person is equal to, opening curly brace, this is a key, this is a value, comma, key, colon, value. And we could add more and more in here. And these don't need to be strings either. Well, the key should probably be a string. So we could say the age, and then my age is going to be 31. And then fave foods is going to be, let's make this an array. We haven't really talked about arrays too much, but let's make this an array of pizza, tacos, and subs. And so when I type in person now, we can see that we get this object. Age, fave foods has an item with 3 items, or has an array with 3 items in it. Job, teaching you JavaScript, name is Caleb. Now if I wanted to access this, I can clear this out by the way. Type in person. If I wanted to access this, I could do person. And this is actually trying to autofill it for me. But I could do age. And all this is doing is saying person, subscript this into the age. So get this person and then grab this age key, and it's going to spit out the value of whatever that is. So it's going to look this up. It's going to look up the age key, and it's going to then spit out that value. And this is going to say 31. Likewise, if I said job, this is going to look up this whole object. It's going to then look up the job and spit out teaching you JavaScript because it's looking for this match here. It's looking for the key. So you go object, key, and then you're going to get the value of that key, teaching you JavaScript. And that is pretty much all there is to it. Now you might be thinking, well, why would I ever use this? Well, because you could say const name is equal to Caleb. Then you could say const age is equal to 31. Then you could say const job is equal to, I don't know, coder. Now that's all fun and games, but what if we need to talk about a second person? Now we're talking about const name 2 is equal to Zephyr. Const age 2 is equal to 4. He's a cat, by the way. Const job 2 is equal to napping. But look at all these different variables we have. We've got name, age, job. Name 2, age 2, job 2. Whereas we could say person, given all this information in here. We could also do the same thing for another person, or a cat. We could group all of it together, and we could say cat, const cat is equal to name, Zephyr, words, meow, action, nap, size, big, he's a big cat. And so now instead of having to write const cat name or cat name or const cat words or const cat action, I can simply write cat action. And that looks it up for me. Looks it up by its name, which is really, really nice. And that is an object in a nutshell. Now, we're going to be using a lot of these in the future, and you're going to be using a lot of these when you write JavaScript in production, in the real world for a real client. You're going to be using these all the time, so it's really good to get familiar with these. What I would like you to do now is create a person object and a cat object. Go ahead and give them random keys and values. Key value pairs is what they're called. So like cat has a name, he has words or a word, he just says meow. And then an action, he naps, and size is big. Or a person can have like a name, a job, a bunch of favorite foods, and age, all sorts of stuff. Go ahead, give that a shot. Create a couple of different objects, and then try to access some of the values that you see in here down the right side by the key that you see on the left side. Methods of pulling strings. Most variable types come with custom actions attached to them called methods. And so basically what we can do is we can work with a string. So const class, let's call it course, is equal to JavaScript for beginners, or JavaScript 101. Coding for beginners, something like that. And so we have this course that we can write in here. If I could ever type that right. There we go, course. Now, let's say we wanted to find something in here. We could, because we know this is a string, we could do dot. And because I'm in my console, it's going to give me all sorts of things that I can do. And we're not going to go through all of these because we're going to be here literally for hours and hours and hours just going through all of these. But we'll go through some of the popular ones here. So we could do search. And what we're going to search for here is the word coding. And that says 16. And so what that's going to do is give us 16 characters in. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, that's a space. 2, 3, 4, 5, 6. And so at the 17th character, and actually what this is it starts at 0. So 0, 1, 2, yada, yada, yada. This goes up to 15. 16 is the C. So starting at 16, technically, because when we're talking about indexes, and that's what this is an index, computers start at 0. So J0, A1, V2, A3, S4, C5, etc., etc., etc. And to prove that, we can do course 0 gives us the J. And let's do 16, gives us the C in coding. Now let's go ahead and clear that and type in course once more so we know what we're working with. We could also slice. We can say course.slice, and let's start at 16. And when should it end? 16, 17, 18, 19, 20, 21. Let's see if I got that right. Nope, that's coding. We coding good. There we go. Coding. And so that's going to, like it said, when to start and when to end. And it tells us that. F stands for function. Start where? At the 16th character. Remember, it starts counting at 0, so it's actually the 17th. And then end where? At the 22nd one. We can also do substring. Substring, very, very similar thing. 16, and the length, instead of going from 16 to 22, we could say 1, 2, 3, 4, 5, 6, 7, 6. And that gives us coding. So it starts at 16, at index 16. Remember, that's actually 17 because we start counting at 0. And go for 6 characters. Let's go ahead and replace something. Coding.replace. Coding, or course.replace coding, and we're going to replace coding with the word programming. And now it says JavaScript 101, programming for beginners. Now, I didn't reassign that to course, so it's going to go back to coding. But what I could have done was course is equal to, oh, look at that. Cannot reassign a constant. Typical Caleb. Should have known better. I should have used a let. But that's okay. Now, what else can we do? We can do course.to uppercase. That makes it all uppercase. We could also do to.lowercase, lowercase. And that makes it all lowercase for us. We could also say something that has a lot of spaces in it, like const something spacey, lots of spaces before and after. Spacey has a lot of spaces. We can do spacey.trim, and it gets rid of those extra spaces for us. That's really important to know, because as soon as we start working with user input, users tend to add a lot of weird spaces for some reason. We're going to want to get rid of those, and that's how we get rid of them. Last but not least, we could do, let's go back to using course. Let's split all of these by a space. So we could say words is equal to course.split. And what is it going to split by? A string with a space in it. So it's going to grab that and split it there, split it there, and split it there. And this is going to give us a list. This is going to give us an array. And so words simply says JavaScript 101 coding for beginners. And if we do type of words, we're going to see that this is also an object, but technically it's an array. And we can see that in its proto here, it says an array. Now, what I would like you to do is try to give most of these a shot. Try to do some of these on your own. So what you're going to need to do is create a brand new variable. Call it something long with a bunch of spaces. And I want you to try to use .search, .slice, .substring, or substr. Substring technically is a different function. .replace, .to uppercase, .to lowercase. I want you to try all of these, including .trim and .split. These are very, very, very common methods on strings in JavaScript. So you're going to want to make sure you try all of these out. You don't need to be a professional at all of these, but you need to at least get a little bit of experience so you can, know what to expect. Go ahead and give that a shot, and when you're done, come on back. I'm going to show you one more thing. Okay, hopefully you got a little bit of experience with things like split, .to uppercase, .replace, .search, .trim, things like that. There is something else we can do. So course.length. Now this doesn't come with the curly, not the curly braces, but the parentheses at the end. This is just .length. This is called a property. Whenever it has opening and closing parentheses, whenever it has a set of parentheses here, that's called a function or a method. Without it, it's called a property, and this tells us how many characters are inside of it. Last but not least, we can also do course, and then we can subscript this with a number. So we can say course, hard brackets, and let's say 9 is going to be T. Okay, didn't know that. 0 is going to be J. There's 36 characters in here. That's probably one too far. There we go. S. And why 35 worked and 36 didn't? It starts at 0. So if we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. We land at the S here. Whereas if we land at the 36, it's sort of over here. There's nothing there. And that's again because of index offsetting. We start counting things at the number 0. Demystifying variable types. Whenever you're working with someone else's code, you might not know what the variable type necessarily is. Variables can go through a lot of different states, and maybe a variable is a list at one point or an array. Maybe it's an object at another point. Maybe it's a string at another point. Maybe it's a number at some point. Ideally, that doesn't happen, but occasionally it does. And you can always run a particular function called type of. And so to run from that last lesson, I had a variable called course, and it was a string. And I can do type of, and then put the variable name in there, and it's a string. Let's also go ahead and make a list, an array. So ARR is equal to just an empty list, an empty array, and we could say type of ARR, and this is going to look funny because it actually says it's an object, but if we do ARR, proto, it's an array. So you just got to be a little bit careful with that one. Let's go ahead with const boolean is equal to false, and then we can do type of boolean. It is a boolean indeed. And if we do boolean, we can see that it's false. We can do that with any variable at any point in time. Now, what I would like you to do, go ahead and give this a shot. Create a new variable. Create a few different variables. Try creating a Boolean, try creating an object, try creating an array, try creating a string, and then run type of on all of them. This should really only take you about 2 minutes. When you're done that, let's go ahead and talk about casting data types like a wizard. All right, let's talk about casting data types like a wizard. You're a wizard, Harry. Hama one. Okay, now that I'm done with the silly sound effects, let's talk about casting data types like a wizard. So casting is the ability to actually turn one variable type into another variable type. And so, for example, we could say age is equal to 31 as a string. And that's already assigned. We got to refresh. Age is equal to 31 as a string. Nailed it. And so we can say type of age, and that's going to give us a string. Now, what if we wanted to times that age by 7? We could do age times 7, and that works perfectly fine because JavaScript is loosely written, so it understands that this is, in fact, well, it's supposed to be a number. It's in a string, but it can be a number. What if we went with age is equal to, my age is 31, and then did age times 7. Returns NaN. That stands for not a number. Now we're getting to some sort of problem. Now we have age. Nope, age is supposed to be 31. Let's say we want to cast this as a number. All we have to do is type number with a capital N, throw in that variable, and it's now that. Well, it would have been, actually, because age is still going to be a string. We can see that it's a string. If we did age is equal to number, and then threw the age in there as well. So we're overwriting it, and now we can say type of age, and we get number. What happens if we want to cast a string, or an object, or an array? We can do all of these things as well. So we can do age is equal to 31, and then we can cast that. So we can say age is equal to number, age. We know that that's now a number. We could also do object, so we could say age is equal to object age. This is going to give us something weird. This just says it's a number, and it's got a primitive value of 31, so it is an object, technically. It's a weird one. We probably wouldn't want that. We would probably actually want to do something like person age is equal to whatever that age is going to be. But that is one way to do it. Let's go ahead and, what do we have here? Age. Let's do age is back to 31, so this is now a number. This is going really fast. We can do age is equal to array age. And we have a length of 31. Interesting. But there's nothing in it. But we are casting things in here. So this is getting a little bit weird. And honestly, you're not actually going to but you're not going to cast things to an array or to an object too often. Once something stays as an array, or once it's created as an array, it stays as an array. Once it's created as an object, it stays as an object. Strings and numbers are a little more interchangeable because they're similar data types, but arrays and objects are pretty different from just a simple number, so it's going to be a little bit different. One that you might want to use a lot, though, let's see what age is. Age is equal to 31. Type of age gives us a number. We could try a Boolean, and this is going to be very helpful to understand conditionals at some point, because everything boils down to either true or false in programming. And so what if we did age is equal to 0? And then we cast that as a Boolean. We get false. And that's because 0 is false, 1 is positive. What is Boolean if we say -1? That's true. What about -10? That's true as well, but just 0 is false. 1 is true. 10 is true. Everything boils down to true or false, and in JavaScript, all Booleans that are zeros are false, everything else is true. Now, why is this lesson even important? Why am I teaching you any of this at all? Because occasionally you're going to want to change something, one data type, to another data type. You're going to want to change 31 as a number to a string to do something with it. Because, and here's a good example, age is equal to 31. Let's do age is equal to 31 as a number. Age dot, well, this doesn't have things like replace. What if we wanted to replace all the ones with 3s? So we make 33. Well, this is going to give us an error. It's not a function. We now have to cast this. We can say age is equal to string age. We know that that's now a string. We can see it in here. It has quotation marks around it. And we can do age dot replace 1 with 3. And that gives us 33. Now, that sounds like honestly, like a really bad example, but it's not. These are things that you're going to have to do. And the reason we want to do this, another reason we want to do this, is because whenever you're working with user input, it always comes back as a string. So if you ask a user, how old are they? They could say, my age, 31, but it's going to come back as a string. It's not going to come back as a number, it's going to come back as a string. Now, what if you need to do something with that particular number? You could say age is equal to prompt, what is your age? And watch this. This is going to prompt me. I'm going to put in 31. I'm going to put in a different number here. I'm going to put in 50. 59. And it comes back as 59. And what if I do type of? Nope. Type of age. Comes back as a string. Now, that's cool. I can do things with strings. But what if I needed to do something else? As in, I needed to add something together. So we can say my age is equal to 31. And then we could say console.log, our ages together are, and we're going to concatenate these using the old school way. And this is just how we merge things together. We merge sentences together using concatenation using the plus sign. So we have a string here. And then in here, we just concatenate our variable age plus my age. Our ages together are, and actually let's just leave it at that, and let's close that console log. And we see a problem here. Our ages together are 5,931. Well, that's not right. What if I did my age plus age? I get 3159, or my age, or the other way around, age plus my age is equal to, it's adding a string and a number together, and so it's coming back as a string. We don't want that. We need to cast this. And so if we cast these both as numbers, we can add these together. So let's do this. Age, currently a string. Let's do age is equal to number age. And let's do my age, 31. And now let's add these together. Age plus my age. There we go, we got 90. Now it's actually doing proper math. This is really, really helpful in the simplest form of JavaScript, is we need to be able to cast these things from one data type to another. It's really, really important that we do that. Now, you might not use this right away, but you will use this down the road. It is very, very vital to know how to do this. Now, you probably shouldn't have to do anything at this point. I would say if you want to get some hands-on experience, try casting from a string to a number and then back to a string. And kind of doing what I did. Feel free to watch this video a couple of times because I went a little bit fast and it's a little bit tricky to understand at first. I get it. But also know that you don't need to know all of this right away. You can pretty much tuck this in your back pocket for now, and tomorrow or the next day when you come back and you want to dig into JavaScript some more, that's cool. You have this in your back pocket. You can now work with casting a little bit and experiment with it at your own pace, of course. All right, let's talk about concatenating variables to make sentences. So concatenation, or concat for short, is a ridiculous term for mixing variable types together and sort of merging them together into one big sentence. That is literally all it is. So in older JavaScript, you're going to see something like, my name is my name, age is my age. Now, this actually isn't going to do anything because these variables aren't set. Let's go ahead and set these variables first. Name is equal to Caleb, age is equal to 31. And we can write this. Oh, that was not quite right. There we go, a little space in there. So Caleb is my name, 31 is my age. And this is concatenation. So we have a variable plus a string, plus a variable, plus a string. And then it ends with a semicolon, as it usually does. That's old school JavaScript concatenation. In modern JavaScript, you're going to see these things called template literals, which again is a really fancy term for basically just putting your variables inside of a fancy string. And so instead of writing it this way, which honestly gets really confusing, you're going to see this using backticks. So we write this backtick and we could say, my name is $, and then opening and closing curly brace, name. And my age is $, opening, closing curly brace, age. And you close it with a backtick. And this is a template literal. And doesn't this look a lot easier to read? My name is name and my age is age. Versus name plus is my age, is my name, plus age plus is my age. This is just a lot easier to read. And this is modern JavaScript. Again, this is called a template literal. Template literal. Why is it called a template literal? I guess it's a little more literal in the sense that you can actually read it. I don't actually know. I feel like sometimes us developers name things just to make ourselves feel smarter. But that is a template literal, and you're going to find this in ES 6 and up, so this is actually quite modern JavaScript already, and you're going to see me writing it this way from now on as well, because typically this is just, there's nothing wrong with it, it's just a little more old school and a little harder to read, and I want it to be nice and easy for you to understand. So know that there are two different ways to do it. You're going to see this way out in the wild, out in wild JavaScript land when other people are writing JavaScript. You're also going to see it this way as well. Remember, with a template literal, you need that backtick. If you do a template literal without the backticks, this is what happens. It literally does this. That is not what you want. You want this one. Nope, wrong one. You want this one. Well, they're both the right one. You want both of these. Nailed it. So that's concatenation in a nutshell. Go ahead and give both of these a shot. You're going to want experience from both of these. Numbers are tricky, but they don't need to be hard. So you've heard the saying, it's tricky to rock a rhyme that's right on time. It's tricky. Numbers are not tricky. No, numbers are tricky. Oh no, I messed that up. Numbers are tricky, but they're not hard. So sometimes we need to cast variables like numbers to add them together. For example, if we have something like num is equal to 1, 2, 3, num2 is equal to 4, 5, 6.7, and then if we did num plus num2, we're going to get something weird. We get 1, 2, 3, 4, 5, 6.7. Even though we just wanted to add these together, we ended up concatenating these together because one is a string, one is a number. Now, if JavaScript detects that both of these are numbers, it's going to add those together for us, which would be really delightful. But it says one is a string, so it concatenates together, assuming we know what we're doing. And sometimes we do, sometimes we don't know what we're doing. And so in order for us to get past this, we can say num2 is equal to number num2. And all this is going to do is cast it to a number. And now we can say num plus num2, and that's going to add them together. And this is where sort of casting comes together along with concatenation and sort of understanding data types. Everyone likes lists, right? Or is it just me? I think a lot of people like lists. I like lists for sure. So in JavaScript, a list is called an array, and we've actually touched on this a tiny bit, and it looks a lot like this. We've got some sort of list, lst is equal to, and then opening and closing hard bracket, and then we can put anything in here. We can put 1, 2, 3.0, 4. We can put another list in there. We can put an empty object in there. Done. And if we do type of lst, that's our list, we get an object, but if we click down in here into our proto, we see it's an array, and it comes with all sorts of different functions in here. We've got concat, constructor, copy within, filler. Oh man, there are just so many things we could do in here. But we're not going to cover all of those because we don't want to be here for a short lifetime. So I'm just going to clear that console and retype lst so we know what we're working with. And so the syntax is really just a hard bracket, and again, it looked a lot like this. lst, or const lst, or let lst. We could do const lst is equal to open the array, and then we have our first item, and then we have a comma, then usually a space just to make it nice and readable. Then our second item, then a comma, and then a space, and then a third item, and we have all these different commas. And so we've got comma, 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 chameleon. And that is how we add all these different items to an array. Now, an array is, honestly, at this point in time, it's completely useless to you. There's nothing you can do to it or with it. So let's go ahead and just cancel this. And let's do lst. Let's add something to it. Let's add a new item. New item here. And we can do LST, nope, LST. And that's going to give us a new item at the very end. And so all we did was list.push or array.push. And instead of LST, you'll often see people refer to it as ARR for array. LST.push, new item here, gave us the total number of items in this array. And then in this array, item number 7. So 1, 2, 3, 4, 5, 6, 7. But remember, we start indices or indices at 0. Our last item here is new item here. Now let's say we want to get that out. We could say const new item is equal to lst.pop. And this is going to do two things. New item is now the new item here, and also lst no longer has that 6th item in here, or the 7th one technically, but index 6, it didn't have that in there. So if I scroll on up, this is what it used to have right in here. And if I scroll on down, it's no longer there. We popped it out of there. We popped it out of the array into a new variable. And so that's how we put things in and take things out of an array in a very, very simple way. I think there's like 9 other ways you can take an item out of an array, but in this case, we're just going to keep it easy and simple with .pop. Iteration. Okay, let's take a look at lists or arrays, because on their own, they're actually not very useful. They're actually super useless. We need to be able to do something with them. So there are 2 ways to loop over an array. We can use the for function or the for constructor, or the for each function. So the for loop or the for each function. And so one looks like this: for something as long as something else after each iteration, do some sort of thing, code here. That's basically what a for loop does. So let's go ahead and demo this real quick. So let's create a new const AR is equal to 0, 1, 2, 3. And we can say for let I is equal to 0, so a starting value. Then we can say do this over and over again for as long as this next part is true. So I is less than arr.length. So now we're using the .length property, which we learned about. With strings, it just happens to be that arrays have that too. And then at the end of each iteration, do I++, which is a declaration operator, an incremental declaration operator, and that just adds 1 value to it. So after each for loop, it's going to go from 1, 2, 3, 4, all the way to the end until this reaches that number. So as long as I is less than 0, as long as I is less than 1, 2, 3, 4 items, we should be good. So what we can do here is console.log I, and let's just console log that. And so we get 0, 1, 2, 3, and undefined. And so now what we can do here is we can say console log ARR and use that number as an index as I. There we go. So it's going to console log ARR 0, 1, 2, 3. And we can see this when we do I. So basically this is your index. So it's going to console log the index and then the array with that index in it. Let's go ahead and see what this produces. There we go. 0, 1, 2, 3, and classic undefined. We don't really care about that at the moment though. We can simply ignore that at this time. So that is the for loop, and that is simply going to loop through all of the items in an array. Now there's actually a better way to do this, and this is a more modern way, and this is the way I really prefer to do it. So arr.forEach. And then we can say for each of the numbers in that list, console.log said number. And so we're actually using some pretty modern JavaScript here. We're using a for each function. This is not a loop, this is a function. And in here, we're passing in 1 parameter into a function. We haven't learned about functions yet, but we will. We'll get there. And we're using a fat arrow function, which again is also a very modern JavaScript thing to do. And so this doesn't work because I need to close this opening bracket there. There we go. 0, 1, 2, 3, and undefined is whatever it's going to return. That's fine. So what I would like you to do is give both of those a shot. This one is the main one because this is what you're going to see more often these days. But if We take a look at this one. This is also old school. A lot of new JavaScript is going to compile down to this type of JavaScript anyways, just so that it can support old browsers like Internet Explorer. So you are still going to see this kind of for loop, but you will also see this a lot more commonly these days. So make sure you get familiar with both of them. Give both of them a shot. Don't forget, the main thing here is you need some sort of comparison while this is true. Otherwise, you could possibly end up crashing your browser. You only crash your browser, not your computer, so you'll be totally fine. But if you only did something like this is going to say for I is equal to 0, while something is true. Well, we know for in Boolean is true, so this is going to be true. Do I++, and I need to get rid of that. Do I++. And so this is not actually going to ever meet some sort of ending condition. And so you want to make sure that I is less than or less than equal to arr.length. Up next in the next lesson, we are going to talk about selecting more than one element with classes. I am getting really bored of using this console. You know, this is great and all. This is using our browser, but let's go ahead and do something funner with like maybe CodePen or something in the next lesson. By now, we know how to select an element by its ID. What if we want to select an element by its class? Well, if we select an element by its class, we're at risk for selecting multiple elements, and this is going to get into some strange things. So what I'm going to do here is actually tuck away VS Code for a little bit and open up CodePen. All right, so here I have codepen.io open, and I'm going to close up this CSS tab, and in HTML, I'm just going to write a little bit of HTML with a little bit of CSS. Or a CSS class, not CSS. So I want to use Emmet abbreviations, and I'm going to write dot, and then this class. And I'm going to copy this a few times. This is a class 1. So at this point, we have 4 elements with the class name. This is class. Now there's 2 ways to grab an element by its class. We can use document.querySelector or document.querySelectorAll. There's a difference here. Let's do const elements for elements, document.querySelector, and we're just going to write the CSS selector. So this class. And then let's do console.log lms.inner text. And we're going to see that this is class 1. It's only grabbed that very first one. Now, if we want to grab something by a class, we might want multiple elements. And so we can do this as well, but we don't use query selector. We use query selector all, and this is going to return, instead of a single node or single element, it's going to return a single list of elements, or a node list. And so if I go in here and console log elms, we're going to see, oh, look at that, we found a limit in CodePen. That is unfortunate. Okay, so what I'm going to do is I'm just going to copy this. I'm going to throw this in VS Code real quick. Copy that. Throw that into my script. And go back to here and just refresh the page. And this is left off from the last lesson there. So here we have a node list. And in this node list, we have the 0th item, and first item, second item, and third item. This is because, well, this is an entire class. And so if we go into the first one and we scroll down, there's a lot of stuff that we can have here. But if we scroll down to inner HTML or inner text, it says this is class 1. Okay, cool. If we want the 4th one, let's go to that last one there. And remember, indexes start at 0. So 0, 1, 2, 3 is the same as 1, 2, 3, 4. And let's scroll down to inner HTML, inner text. We've worked with these before. This is class 4. And so what this has done is given us a node list. And we have in our code here const elms. So we can access this in our console. And we can do type of elms. Gives us an object. And classic, because a lot of things in JavaScript are objects. It's an object-oriented programming language. But if we, again, just type elms, we can see that this is, in fact, a node list. And if we click down, proto, this is a node list. That's the kind of object it is. It's a node list. So to recap, if we want to select one single class, and it's just going to get that first one, we use document.querySelector, and then we write our CSS in here. And this is why it's important to know CSS while you're writing JavaScript. we could do this class, and this is going to give us the first one. So we could do inner text, and this is just going to say this is class 1. Whereas if we wanted to grab all of them, we would say document dot query selector all. Same thing, this dash class, and that's because in our code here, this is our class name, this class. This is going to return a node list, and then we can loop through that node list, changing every item in a list. Let's go ahead and get a list of elements using document.querySelectorAll, and let's go ahead and work with that. Let's change something. So first of all, we want a list. Let's do an ordered list here, an OL. That's going to give us 1, 2, 3, 4 in sort of bullet point styles. And then our first one could say this is 1, second one could say this is 2, and the third one could say this is 3. Now when I refresh my page, it says this is 1, this is 2, this is 3. Now what we can do here is we can say something like const elements is equal to document.querySelectorAll, because we want a list, a node list, not just one of them. We want a node list, and we covered that in the last lesson. And we want to select just the li elements. And this is where knowing HTML comes in, is because we are going to now select every li element on this page. So if we go ahead and we select that, we have elements. It's a node list with 3 li's in it. Let's check that second one just to make sure that things are looking right. If we go into the inner text here, it should say this is 2. Where is it? This is 2, just like that. And that's pointing to this one here. So that's good news. This is working the way we want. Now to loop through this, we can use a for each. So we can say elements.forEach node fat arrow, and then we can do node because it's going to loop through each one of these. So it's going to loop through li1, li2, li3. And we know that there's an inner text value in there, or a property. We can do node.innerText is equal to this is changed. Let's close that, and we close that with a closing curly brace that selects this, and then we close it with a closing parentheses, and that selects all of that. Let's go ahead and hit enter, and we're going to see that this changes on the left-hand side as soon as I hit enter. Bam, just like that. This is changed. Now, what if we wanted to, for some reason, know which index item this is? Well, that's going to be a little bit hard. We could have our own little for loop. We could keep track of it. We could write a variable saying index is equal to 0, and then inside of here we could say index plus plus. We could do something like that if we wanted, or we could use the for each index parameter. And so we could do elements, and actually what I'm going to do is just clear that. We could do elements dot for each, and now instead of just saying node, we're going to say another parentheses, another bracket there, node, and then index, and then our fat arrow. And then we could say that node.innerText is equal to, and we're going to use a template literal here. Hello, this is item index. And let's close that. And as soon as I hit enter, this is going to say, hello, this is item. You tell me, is this going to say, is this item 0? Or is this one item 1, item 2, item 3? Item 0, 1, 2, or 1, 2, 3? Remember, indexes always start at 0. Hello, this is item 0. What we can do instead, actually, if we wanted to offset that, is in our template literal here, we could say, where we have these opening and closing curly braces, we could say +1. I'll make that just a tad smaller there. So we could say, use the variable index, remember it's got a $sign there, +1. And this is going to give us that offset that we're looking for. So it looks a little more readable in human terms. So it's going to say, this is, hello, this is item 1, hello, this is item 2, hello, this is item 3. Just like that. Hello, this is item 1, 2, and 3. Now, what if in JavaScript we wanted to loop through all of these and we wanted to add a class? And so each one of these, if we go into our elements, li, none of these actually have a class. We could add a class to it if we wanted to. So we could loop through all of these. We could say elements dot for each, and we're just going to use a regular node. And because one thing I skipped in the last little section there is because there's two parameters, we use brackets around it or parentheses around it. when there's just one, we don't need parentheses. We can just assume that it's just a node. And so that's what we're going to do. We're going to skip the parentheses here. Then we can say node.classList.add custom class, and let's add a second one, second class. Now this looks like it's not going to do anything, but if we go back over to elements, we can now see that custom class and second class have been added. And this is a really good way to dynamically change your page when the page has been loaded. And so you can have a boring plain page like this, and when your JavaScript is done loading, for example, you could say loop through all the LIs on a page or loop through all the divs on a page and add a particular class so that your site looks like it's loading dynamically. Now, we have been working with this a lot, this sort of functionality where we've got like the word add and then a parentheses and then some sort of parameter, maybe a second parameter. And when it's attached to an element like this, it's called a method. But when it's not attached to an element like this, it's called a function. And in the next lesson, we're going to start writing some functions, or we're going to at least take a look at what functions are and why they're important. Staying dry in code rain. So let's talk about this. Dry. This is the concept of do not repeat yourself. Actually, it's don't. It's don't repeat yourself. And the idea here is that you write code once and you don't have to write it again. Now, dry is a really nice principle because it allows you to write code once, and if you have to change it across your site and it's being that particular piece of code is being accessed like 20 or 200 times, you can change it in one place and it changes it everywhere. So for example, you could ask for someone's age. You could say the const of someone's age is 31. Then you could say if age is greater than or equal to 18, they can vote. If the age is greater than or equal to 21 in the United States, they can drink alcohols. And then you can ask for a second person. So you can say second age is equal to, let's say 15. If age is greater than or equal to, you can see how this is becoming pretty repetitive already. They can vote if their age is equal to or greater than 21. Yes, I'm doing this the long way for a reason. They can drink alcohols. Now, what if there's a third age? Third age is equal to 20. We have to do the same thing. If age, okay, you get the point. This is going to go on forever and ever and ever, and it gets really, really repetitive. And you can see that I'm actually writing the exact same code here as I am here. So why not just wrap this up into something that can be used once, or written once and used over and over again? And that's what we're going to do with functions. So functions look scary at first, but they actually aren't anything to be afraid of. And so a function looks a lot like this. We use the keyword function and then some sort of name. Let's say add numbers. And then this can be, let's just, there we go, add numbers. And then this could have some sort of parameter, a parameter 1, a parameter 2. The parameters are separated with a comma. And then we use an opening and closing curly brace. And all of our code goes in here. And then lastly, we can have some sort of logic, do something with parameter 1, do something with parameter 2, and we return an answer, and we return it with the return keyword. So this is the syntax for a function. And so we've got function, our name, it could be any name, parameter 1, parameter 2. If there are parameters, there might not even be a parameter. Then we've got an opening curly brace. And then all of our code goes in here up until it reaches that closing curly brace. That's going to be contained in the function. And then we have the return keyword, and that just spits out an answer. And so when we use the return keyword, that means we can now do const total is equal to add numbers. And this is going to now say an answer. And so let's go ahead and actually save this and run this in our browser. So let's go back and refresh. This is just HTML from the last lesson. What did I call it? I called it total. Let's go ahead and console.log total. If we don't want to console log total, we can always just write total in our console. and we get an answer. And so what we've done here is we've written some sort of code that we can apply over and over and over again. We can basically keep doing this. Well, that's better because we can't overwrite a const, but we can overwrite a let. What we want to do here is basically say, keep adding these numbers together, and it's going to keep saying return an answer, and they're all going to be an answer. So the idea here is that if we have 300 lines of logic, right? If we have 300 lines of logic, we don't have to write 300 lines of logic for this line, and then for this line, and then for this line, and for this line, and for this line, and for this line, and for this line. We can literally write it once and access it using that function name. So in the next lesson, we're going to go ahead and actually start writing a function. All right, let's take a look at finding the fun in functions. Functions are how we reuse code. And this follows the principles of dry. Do not repeat yourself. Dry. Don't repeat yourself. Dry. And so this is really nice because we can start writing larger pieces of code and not having to copy and paste. And when something changes in the future, let's say we have a typo somewhere, we don't have to change it in 20, 30, 40, 50 different places. So let's go ahead and create a function. We have the keyword function, add numbers, and then this can take either 0 parameters, 1 parameter, doesn't matter. It can take unlimited parameters. So let's do, not parameter 1, let's call this number 1, and let's call this one number 2. And what we're going to do here is say const total is equal to num1 plus num2. Return total. Now remember, I'm using const here, and so this is going to be scoped to these curly braces. That means I cannot use total outside of this particular function. Now I could redeclare it. I could say const total and create a new const out here, and that's totally fine, but I cannot access this one outside of the function because it only lives within its closest set of curly braces. So actually, let's go ahead and do that. Let's say const added total is equal to add numbers, and so I'm just using the function name now, this function name, number 1 and number 2. We could do number 1 and we could do number 2. And so if this adds 1 and 9 together, this is going to return the total of 10. Let's go ahead and save that and refresh our page over here. And for anyone who's just coming in, by the way, in my index.html, what I can do is get rid of that. I'm using a script element, and I'm using the src attribute to link to my script.js file where I have all of my external JavaScript. It's just a little nicer than having to write it internally inside of my HTML file. I can write it just in a JavaScript file itself. I get nice syntax highlighting and stuff with VS Code as well. So let's go ahead and refresh. Added total is a const that we have written in our code here. This code has now been executed. I now have access to this in my console. I get 10. And so to see this in action, we could do function greeting. We could ask for someone's name, and then we could say console.log, use a template literal here. We can do name, just like that. Now this isn't going to do anything. This is just going to declare the function. Cool, nothing happened there. But if we run greeting Caleb, we're now going to see it says hello Caleb. It's going to print that out for me. It says hello Caleb. And let's do that again. Greeting Zephyr. Hello Zephyr. We could also put this into a variable if we wanted to. So we could redeclare that function, and instead of saying console log, we could simply return. And when we return that now allows us to store that in a variable. So I could say greeting Zephyr with the parameter of name. So that first one is going to be Zephyr. And it's going to say hello Zephyr. And it's going to do what we want, but it's not actually going to go into any sort of variable yet. We could say const cat is equal to greeting Zephyr. And now we're going to see that nothing happens here, but if I type cat, hello Zephyr, now I have access to this over and over and over again. And so what we've effectively done with a function is we've written a little bit of code. It's taken a couple of parameters, or in that last sort of example with Zephyr, we took one parameter named name, and we did some sort of logic in there. We did something, and then we just returned it. And basically, you can think of this sort of like a black hole. This will take anything you throw at it, literally anything you throw at it, and it's going to possibly spit out one thing, Hawking radiation. And then we can reuse that over and over and over again. So we could say added total, we could add these numbers, added total, let's do added total 2. Let's add ridiculous numbers. I have no idea what that is going to be. And then let's go ahead and added total 2. That's our number. So it's adding it for us. We no longer have to actually worry about doing math. We can just tell it to do the math for us, which is really nice. That is the programmer way to live life. You don't need to know how to do the math. You just need to know, well, how to do the math once, and then you never have to think about it ever again. Now let's go ahead and break this example. What happens if I don't give it a number? This is a data type that we're working with here. We're using the number data type of 1 and a number data type with a value of 9. What if we added strings in here? Let's go ahead and add these totals together. So I'm going to save that, refresh this page, and just access that. Well, this gives us 19.123. Not what we wanted. We wanted 10.123. This gave us 1 and basically did this. It concatenated it for us. So what we can do now is we can force these to be numbers. Number, number. And this is typecasting. This is where typecasting gets really, really useful. And so we can say in this function, even if you pass in a string, change that data type to a number. Same thing with number 2, and then total those together. Now let's go ahead and refresh that page. And we're going to see in here, added total is going to be 10.123. And it's not going to be 19.123 as a string, which is what it was originally. It's an actual number this time. So now we're mixing typecasting with functions for reusable code. And this is going to produce the same answer every single time. It's going to be very predictable. And that's what we want in our programs. We want our code to be predictable. Now, one last thing. If I create, or copy, not create, I've already created it. If I copy add numbers together, let's take a look at the type of here. So we know add numbers is some sort of function. When I type that, we get this weird sort of italicized F. That means it's a function. We can do type of add numbers, and it tells us it's a function. Now here's the kicker, is if we do add numbers and actually execute that function with the curly braces, let's say 1 and 9 again, this is going to say the type of is a number. And that's because it's actually going to execute this. It's going to execute it, and it's going to return 10, and then it's going to say type of 10 is a number. And so if we do this as an example, gives us the exact same thing. And that's simply because this is now returning an answer. It's returning this 10 and saying type of 10 is a number. Whereas if we don't use those parentheses, and we just give it the function name, we can see that the type of is a function. We've worked with type of before. We know of numbers, booleans, strings, objects, arrays, null, undefined, things like that. This one is a function. Now this is absolutely vital to know in JavaScript and in most programming languages. What you're going to need to do as your homework, and I don't want you to carry on until you give this a shot, is I want you to create some sort of function that takes 1 or 2 parameters and multiplies them together. So you could do something, and I'll show you an example here. You could do something like function times num1, num2, return num1 times num2. I want you to do that and then assign that to a variable. So give this a shot, play with it. Try changing num1 to a different name and try breaking it. Completely 100%, 1000 trillion%. Try to break your code. That's how we learn. We learn by breaking code, and you're not going to break anything on your computer. This is completely safe. So go ahead and give this a shot. Have some fun with it. Try to break something. Learn what does work, what does not work. And when you are done, let's head on over to the next lesson where we talk about accepting an unlimited number of parameters in a thing called a REST. Okay, let's take a look at Well, a rest. And the title of this one is Finding the Fun in All the Rest. And so this is kind of punny in a boring programmer kind of sense. And we don't need HTML or CSS. I'm going to do this one in CodePen. And so a rest looks like this, ... That's all it is. And this is relatively new in JavaScript, but you're going to see this all over the place because it is incredibly powerful. Also, for a little while, let's hide that console. We don't need that for a bit. And so in a function, we can use a rest as a way to accept unlimited number of parameters. And so we could say function add numbers ... numbers. And then in here, this is going to be an array or some sort of iterable that allows us to loop through those. And so we could say for index in numbers, and this is a different type of for loop. It's the same type of for loop, it's just written in a different way. So this is going to give us the index. We could say console.log, and let's just start with the index. And let's execute this. Add numbers 1, 4, 7, 13. And in our console, we can see that it just keeps saying 0, 1, 2, 3, 0, 1, 2, 3. Yeah, that's not really useful, but that is an index. And that means 0, 1, 2, 3. 0, 1, 2, 3. We now have access to that. We can do console.log numbers with that index in there, knowing that this is essentially a list or an array of items. And so we could say numbers index 0 is going to be 1. Numbers index 1 is going to be 4. Index 2 is 7. Index 3 is 13. And now we see 1, 4, 7, and 13. But this isn't actually adding our numbers together. Let's go ahead and add some numbers together. So we could say let total is equal to 0. And in here, what I'm going to do is I'm just going to get rid of that line. I'm going to say total is equal to total plus numbers index. And assuming, I just cleared out that console there, assuming that this is working fine, we should see nothing in the console. Even if we add this together, we should see nothing in the console. And now you can actually see that I'm using total up here. This is actually not going to work. What we need to do is we need to cut that, and we need to paste that in here. And so what this is going to do is say, execute this function, and when this function starts, there's a variable in here called total, and it's going to have a total of 0. Now this is going to be scoped to these curly braces, its outer curly braces, which means we can now actually change that total value in here. And then lastly, let's go ahead and return this, because I forgot that. Return the total, that's important. If we don't return that total, nothing's going to happen. And so, clear that. And I can say add numbers 1, 3, 6, and 9. And that gives us 19. So let's add these together. 1 plus 3 is 4, 4 plus 6 is 10. 10 plus 9 is 19. And that is working for us. We can even put this into a new variable as well. So we can say const new total as one word is equal to add numbers. And then let's go ahead and clear this. And let's just access that. New total, 25. 1, 4, 7, and 13 is 25. And so what we're doing here is we're taking an unlimited number of parameters. Now what we can do is we can add additional parameters here. We could say the first one has to be a greeting name. Let's just make this a touch smaller. This first parameter has to be a greeting name, and then it can take all the numbers. And so we could say in here, well, this isn't going to work, unexpected token. That's not what we're looking for. We're looking for the first parameter to be a name. So let's use my name, Caleb. And then the rest are going to be numbers. And so if I do new total, this is still going to work as expected. We can also use that greeting name. We could say return greeting name, the total. Total is the total. And this is using a template literal here. And let's go ahead and just console log this, console.log new total, so we don't have to type it in our console over and over again. Caleb, the new total, or the total is 25. We could say Zephyr. We could change this to a bigger number. Zephyr, the total is 225. Now, you're not going to see this as often as you see functions, but you are going to see this in the wild, so it's important to know. What I would like you to do as your homework for this, and this is really important, is to give this a shot. Write a function, give it a name, give it a single parameter, a mandatory parameter, and then give it a rest. Then I want you to, at some point, loop through that rest. Loop through the index of the numbers, for instance, and get those numbers. Then I want you to return something with a template literal. So return a string. This is going to be a string because that's what a template literal is. Put that first parameter in there. Put that second parameter or a different variable in there, whatever you're working with. Put that second one in there and then call it. Call that function and execute it. And then console log that. Once you have that up and running, go ahead and move on to that next lesson. But I would highly suggest to not move on to that next lesson until you actually do this, just because this is really, really good practice, and you're going to see this in the wild all over the place. Even if you have to, I'm going to make this bigger, even if you have to, just pause this video here, take a screenshot of this, and write this out by hand. And then just tinker with the code yourself. It's really important you get used to how the syntax is written, making typos, fixing those typos. A lot of junior programmers, I see that all the time. They make typos and they can't figure out why. Don't forget, open up your console. It'll tell you exactly why. And then just tinker with my code if you like. If this particular concept was too hard to grasp for you, and that's okay if it is, copy my code and tinker around with it. So change greeting name from here and here, change it to something else. Change numbers from here, here, and here to something else. Change that starting total from 0 to 10, so it's always going to start at the number 10, so you've got a base of 10. Go ahead, give that a shot. Don't forget, if you get stuck or you need help, come ask questions in the Learning to Code Facebook group. We are here to help. Once you've done that, I'll see you in that next lesson. Objects with functions. You'll often see objects used as a way to sort of namespace things, so they don't have conflicting code. And the idea here is that you could have someone's name, you could have someone's age, you could have someone's height, and you don't have to do things like person 1 name, person 1 age, person 1 height. My console is going to freak out here. Person 2 name, person 2 age, person 2 height. And so you don't need to do that. You don't have to have all these crazy variables all over the place. What you can do is you can put them into an object. And we've talked about objects before. So instead you could have const person is equal to, I'll just make that a touch bigger. The key could be name, the value could be Caleb. Key could be age, the value could be 31. Different data type, it's using a number instead of a string. Height could be a string of 6 foot 0. Let's do this though, 6 foot. And then if we need to create a second person, we can copy that. And we can do person 2, and let's go ahead and clear this. And so now we can access this with console.log person name. And I have one too many not curly braces, hard brackets in there. And that eventually spits out Caleb for me. And so that's the power behind using an object, is we can group these variables, these sub-variables, into a bigger variable, which is really, really nice. And we can also add things to it. So let's go ahead and get rid of person 2, just because we don't need that example anymore. And let's go ahead and say person fave food is going to be pizza, I guess. I guess that's my favorite food today is pizza. And so even though this is a const, this value technically isn't changing. It's saying that this is already allocated a piece of memory, and we can just keep adding to that piece of memory. So that person fave food is equal to pizza, which is the same as saying in here, fave food, pizza. It's the exact same as saying that. We just dynamically created it, and then we accessed it down here. Now, that was a quick little recap on functions, but not functions, objects. But what if we wanted to add some sort of function in there? We could do that as well. So let's go ahead and clear that out and clear this because that's going to get distracting. We could add a function in here and we could call it anything we want. So let's say speak, and we could give this a function and a parameter if we wanted to. We'll get to that in just a second. But let's say when this person speaks, what does he say? What does Caleb say? What do I say? I usually say something like meow because I live with a couple of cats and I like to speak their language. So this, at this point, looks like it's not doing anything. But what we can do is person.speak, and because it's a function, we just add that in there with these parentheses. And so what we're saying is access this person object, access this particular key dot speak, and because it's a function, if we don't use that, we're going to see nothing happens. But if we do add these parameters in there, we're saying execute this function, console log meow. Now we can give this a parameter as well. We can say, what does this person say? What does this person want? Want is equal to, and I'm going to throw a fun little wrench in here. We can give a default value. Want is equal to a string of cookies. And what we could say here is a template literal, meow, I want, and it says meow, I want cookies. And so now we're using a function, and you can use this as a regular function, not necessarily just in an object as well, but you can use this in a regular function where you have a default parameter. So if it's not given, it's going to default to cookies. So want is always going to be cookies. I can change that. What should that want be now? Currently, I've got an empty string, so it's not going to be anything. I'm going to change that to pizza. And it's going to say, meow, I want pizza. Just like that. Meow, I want pizza. And so that's how we write a function inside of an object. Now, in modern JavaScript, you're going to see this written another way, called an object literal. And the idea here is we can simply say speak is going to be a function, but we don't have to declare it as a function necessarily with a key. If it's going to be the same function name as the key, we can just write the key as a function, I guess. So this is getting a little tricky to explain, so I'm just going to demonstrate it. So I'm going to create another function here called talk. And notice this syntax. There's no key in here. And what I'm going to do is just get rid of that, comment that out, just so that my console stops updating every time I type and stop typing. Talk, I can say console.log I am talking. And so down here, instead of person.speak, I can use person.talk. And it says I am talking. Now this is basically the exact same thing as saying talk is equal to function talk. It's just short, it's less typing. And you're going to see this all over the place. This is called an object literal. This can also take a parameter as well. Talking, who am I talking to? I'm going to be talking to Karen. And I am talking, let's just change this to a template literal. I am talking to, and let's just update this in our console. It says I'm talking to Karen, default value. I am now talking to Amanda. And that's going to change that default value for me. So if this is not provided, just like the want variable or parameter, if it's not provided, it's going to use this default value. But guess what? It was provided, so we can now use Amanda instead of Karen. We can go and talk to Amanda instead of Karen. And we can say console log I am talking to, template literal, inside of an object literal. We're making things a little shorter, a little easier to type, a little harder to understand at first until you get used to it. Now, what I would like you to do for your homework for this lesson, and this is really important because you're going to see this all over the place, is create an object, give it a couple of key value pairs, then create a regular function, then create an object literal. That is a function that is basically not saying the word function in it for the most part. Go ahead and give that a shot. When you are done with that, we're going to move on to our final project in JavaScript 101. Okay, welcome to your final project. I want you to work with what I've given you in this course, in JavaScript 101. You're going to need to solve all of this code on your own, and so you should have access to this link. If you don't have access to this link, you can always go to codepen.io/CalebTallien/pen/ and I'll zoom in here. That's what we're looking for. Capital V, W, J, X, Y, capital G, capital R. That's where you're going to want to go. And so I have pre-written some HTML. I've pre-written a little bit of CSS in here as well. And I have given you instructions in the JavaScript. And so if we just scoot this up, we only need to look at the instructions for JavaScript. Now you're going to want to use your console. So if you don't have your console open, just open that in the bottom left. And we can see it's going to immediately start complaining because I didn't give you everything. In fact, I have given you about 40% of what you need to do here, and the rest you need to figure out on your own. And so what I want you to do is go through here, read step by step. Step 1, step 2, there's an example in there. There's a function, so step 3, cast age as a number. Step 4, set the parameter of show dog years. That's this one here. Step 5, select all of the fake input classes. So now we're going to have to read some code. ID, name, class, fake input, fake input. So read all of those and give it a class name of real input. Now this may take a little bit of Googling to find out the solution. We actually did cover how to add class names at one point. But if you don't know how to do that, it's okay to go and hop on Google. And then lastly, just read through the code. So read through the code comments, read through the code, see what's missing, what you think is missing. If you see something like document.getElementById and it's just like it's empty, well, you're gonna have to go figure out what that ID is. We're gonna have to look at that. What is the variable name here? The variable name is name. So let's go in our HTML and do we have something in here called name? Hello, my name is, ID is name. And so we're gonna wanna put name in there, for instance. And now we're going to see whenever you make an update that your console is going to complain. What you can do if you don't want it to complain over and over again is you can go ahead and you can select all of this code and you can just comment that out. And so I just hit command / cmd +/. It's probably control +/ on Windows. But I just went and commented all of that out just so that I can work at one step at a time. So I don't have to worry about all these different issues that are going to come up in the console. So you can just work on one at a time. Now, I want you to pause the video here. Give this a shot. Try to do this on your own. I have given you the instructions. I have given you everything you need to succeed in this final project. However, if you get truly stuck, you can always just resume the video and I'm going to show you exactly how I go about this final project. All right, I'm going to show you exactly how I go about solving this. So first things first, I'm going to look at all of my code. I have a bunch of HTML here and it says, hello, my name is, and then there's a span with an ID of name. It's got a class of fake input. And I am ID age, class fake input, years old. In dog years, I would be ID dog years, class fake input, old. And that should probably say years old. And then I look over at my CSS and I look at real input. There is no fake input class. So if I were to change one of these to real input, you can see it creates an underline here. And that's what we're looking for. So let's go ahead and change that back to fake input because we want to do this purely with JavaScript. I'm going to zoom in just a touch. And I also want my console open at all times. So it's going to complain pretty heavily at me. I just want to make sure it's not going to complain over and over and over again about the same thing. And eventually down the line, it might help me debug any mistakes that I see. So let's start on step 1. Fill in these 3 consts by selecting the right nodes in their HTML IDs. So we've got name is equal to documents.getElementById, and we've got a name in here. So let's go ahead and put name in there. And let's just change that a little bit. Age, we also have age, and that comes in here. And we also have dog years. Where is dog years? This one is just dog years, all lowercase. I'm just going to clear that console just to make sure that it's not going to keep complaining at me. Step 2, set the values. So for example, my node.innerText is equal to something. So set name and age in here. So we can do name.innerText is equal to, what is my name? My name is Caleb Tallien. And then I can also do age.innerText is equal to, I'm 31. And we can see it's starting to update our document object model here. It says, Hello, my name is Caleb Tullian, and I am 31 years old. In dog years, I would be not a number years old, so that's not set yet. So we scroll on down, and we can see function show dog years. It's taking an age as a parameter, and we want to cast age as a number, just in case age comes in as a string. For example, if we were to pull in age.inner text, this would come in as a string, not a number. And so we want to make sure we're always casting this. Let's cast this as a number. And then we're going to multiply that number by 7 and return that age by 7. But we also need to cast it here, so that we're working purely with numbers and not just with strings that are trying to multiply more strings. Let's move on to step 4. Set the parameter of show dog years. Now we can do this a few different ways. We could say 31, that's kind of cheating, but this is going to work. And it's going to say 207 years old. Okay, that's all right. But what if we did age.inner text? Now this is really cool because show dog years is a function that's going to get the dog years. That's up here, the document.getElement by ID, dog years. And that's going to go over to this one. It's going to change that inner text. It's going to change that age to a number and then multiply it by 7 and return that same number. Now, if we don't cast, chances are this is going to work anyways, because this is going to say something like 31 times 7 as a string. And JavaScript is smart enough, it's loosely written, so it's smart enough to understand that that's going to be a number. But just in case, as a good practice, let's cast it anyways. Step 5, select all the fake input classes and give them the class of real input. This may take a little bit of Googling to find the solution, but that's half of what web development is all about. That is a great comment that I actually added for us here, because honestly, Googling is a big part of web development. And so as an example, what I'm going to do is I'm going to actually go and show you how to Google this. So I hop on google.com, and I go over to the search bar, and I say how to add, and I just moved that up into the recording area, how to add a class using JavaScript. And so usually I go straight over to Stack Overflow. How do I add a class to a given element? Stack Overflow has really good answers here. And so I have an element that already has a class. Now I want to create a JavaScript function that will add the class to the div, but not replace, but add. How do I do that? Look at that. The answer is right here. This is the accepted solution. 2,035 people have said this is the right thing to do. Element.classlist.add and then my class, or if you want to remove it, element.classlist.remove my class. And so that's pretty cool. We are only working towards modern browsers these days. We don't need to support Internet Explorer 9, for example. Let's go and use element.classlist.add. Let's go back to our code here, and it's in here, node.classlist.add. We now know what that does. We could do real input, and that's going to change these to have underlines. Let's go ahead and actually change that width. Beauty, that looks a lot better. Hello, my name is Caleb Tullian. I'm 31 years old. In dog years, I would be 217 years old. Now, we do have one more thing. If we right-click and inspect, let's make this way smaller, because that is obnoxious. In our body, this is what we're inspecting. It says fake input and real input. We want to get rid of both of those. So let's go ahead and get rid of fake input. Actually, I think I said I want to get rid of both of those. No, we want to keep real input. We want to get rid of fake input. And so what we can do here, and this is a little extracurricular, but we can do node.classlist. What did we Google here? Remove fake input. And now, if I right click and inspect, this just says real input in here. It doesn't say fake input and real input, it just says real input. And so now we're modifying our DOM quite heavily. We're adding text in there, we're changing classes, we're working with functions, we're working with typecasting. We are doing a lot of different things here. And that is all we need to do to solve this particular